You're listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson from Proteum Machining, and this week I'm joined by Spencer Webb of Kinetic Precision and Antennasis. Welcome, Spencer.
Hey, Dylan. Thanks for having me on. Good to be here.
Thanks for coming on. Appreciate it.
Yeah, I wouldn't miss it for the world. I listen to your podcast all the time.
I definitely appreciate that. So before we jump into your backstory, which looking at your bio, there's a lot to dive into there, but where can they find you on social media, Instagram, all that stuff? And what does your company do?
So I can be found on Instagram at Spencer_Webb_NH, which stands for New Hampshire, not Nicholas Hacco, but and I also have a website, which is kineticprecision.com, which is my machining face. The easiest way to get there is just to remember pfg.gg, and that takes you to one of the sub pages on the PFG stones, and then you could pop around there. And also my commercial daytime job, which is antennasis.com, where I am an antenna designer and general consultant on antennas.
Yeah, I had no idea, or I think I had seen that somewhere on your website at some point, but never realized the depth of that until you had sent me the bio, and I was like, oh my goodness, there's so much more there than just PFG stones.
Oh yeah, no, that's my main gig is antennas, and that's a whole story too. That's been going for quite a while, but I'm sure we'll get to it.
Yeah, so speaking of that, let's get into your backstory. I mean, your bio says you started at MIT, so that's
no, I started way earlier than that.
Oh, well, let's dive into it.
I was born at a very early age. I grew up in a family in Brooklyn, New York, lived in an apartment. My family had my mom being a teacher, and my dad was an electrical engineer. What a surprise. And my sister went on to become interested in marine biology, and she's now a professor over at the University of Rhode Island. And I was a tinkerer from the beginning. In fact, one of my earliest memories was my dad coming into my room and yelling at me for not doing my homework because I was busy cutting open D cells to retrieve the carbon rod in them to make projects. And even earlier than that, I remember my grandparents gave me an electric clock to play with, and I took it apart in my grandparents' house and put it back together and plugged it in to predictable results. And the black-faced, carbon-stained, fingered young me was then destined to become an electrical engineer.
You let the magic smoke out. You want to find out why?
I did. I think it was inhaling some of that magic smoke that, completely damaged me forever. And I'm happy for it. So I grew up in New York. I went to high school at John Dewey High School in Brooklyn, New York, which was then considered an experimental high school where they gave pass-fail grades. And my sister preceded me. So we're 4 years apart. So we were exactly out of phase. As she was leaving a school, I was coming into the school. And I had gotten bit by the bug of ham radio. And my dad is a licensed ham radio operator. And I started I was soldering and building stuff at the age of, I don't know, probably 8 or 9. Not well, but I was. And I got into the radio hobby and started making Heath kits with my dad and doing, building little transceivers from Heath kit and doing all this in a Brooklyn apartment on the 12th floor. I had a dipole antenna strung out on our floor between my sister's window and the kitchen window. And it was about a foot and a half off the bricks of the building on the 12th floor of the apartment building. And, the today me cringes at I'm already doing the simulations in my head of what that antenna looked like. And it's like, oh, I can't believe I did that. But I started using a 2-watt Morse code transmitter, and I was making contacts literally all over the world. And one of the weird things about how my building was positioned, we looked south in the Coney Island section of Brooklyn. I could see the ocean from my window, and I made contacts with Russians and people over the pole with really weak warbly signals all the time. Here's this 12-year-old kid, 13-year-old kid sitting there, as we say in the hobby, pounding the brass and talking to these guys over the pole with 2 watts in an apartment in New York City. It was wacky. But one of those, sometime in there, this isn't a very precise recollection, but the question came up, where am I going to go to school? I guess I was in high school, and I picked one of these books off the shelf that my dad had from the radar series from the MIT radiation laboratories, and I said, I'm going to go to MIT. And they said, okay, fine. And I did. So that's how I got to MIT. So let me preface this by saying a magnificent student I was not. Okay. I enjoyed learning, but I didn't enjoy school. And one of my favorite quotes was from Mark Twain, who said, never let school interfere with your education. And I think I lived that, much to the chagrin of my school teachers and professors. But MIT was an eye-opening experience on many levels. I was, on a electrical engineering track, and the freshman year sort of blew me out of the water for a lot of reasons. And I won't get into the details, but I ended up electing to take a term off. So I went to work that summer and the following semester. And a good friend of mine who was a member of our radio club in Manhattan, I'll give them a shout out. That's the Manhattan Avenue of the Americas Radio Club, also known as MAYARC. And my friend Murray Braverman said, why don't you come work for us at Bulova? Now, as soon as I say Bulova, I'm imagining Josh Hocko sitting up straight in his chair, but not that Bulova. I went to work for a company which was a part of Bulova called Bulova Systems and Instruments. And Bulova Systems and Instruments was in Valley Stream, Long Island, and they made safety and arming devices and timing devices for weapons for the military. Basically, wow. Yeah, it was. And he said, come work for us. I said, sure. So I went to work for them. That was a pretty cool experience. And it sort of was the beginning of my awareness of mechanical engineering and machining, because they made these mechanical devices, which were the safety and arming devices for missiles. And these little devices would have to spin up at a certain RPM as the missile was fired, and only then it would clear a block so that the firing pin can go forward and fire basically a primer, and the rest, of course, is chemical history. It would go boom. And I got involved with the design and building of a test system for these little things. So it was pretty cool. There was optical devices involved. There was they had a thing called, remember, this is about 1980. Okay. So they had the first use of a thing called a personal computer. Okay. In this test stand. Now it sounds funny, but no, seriously, they considered a 555 timer. You electronic nerds will know what I'm talking about. The height of technology. They were very behind the technology curve, not because they were slow or unintelligent, but because everything they did had to be completely reliable. So they were behind the curve because everything they did had to be completely reliable. So I remember it was a PET computer. It was a single board computer with a thermal printer on it, a hexadecimal keypad, and it was this, crazy thing. And this machine had a motor controller and a big motor, and it had to spin this thing up at high speed or at several set speeds, and had an optical sensor that had to look in these little holes as it was spinning and determine the position of a thing. And it was pretty cool. So I was working on stuff like that. And I remember that the technician that was working with me, I was considered an engineering technician or something like that. The technician that was working with me made a wiring error one day, and he wired the 220 volt input to the machine to the 5 volt bus.
Oh no.
Yeah, it was not a good day. So I come in, and he comes over to me with this really long face, and he tells me what happened. And I'm like, ugh. So we dig into this machine, and it was totally cooked. talk about letting out the black smoke. And there was this frequency counter, this Hewlett-Packard frequency counter attached to this machine to make some measurements, and that thing was dead. So this was like an expensive piece of gear. So I rip into it and I fix the circuit board. Some of the circuit board had smoked, had vaporized. And I formed little pieces of wire to replace the traces. And I got this thing all back up and running. And what was interesting was, well, A, I got it up and running. That was pretty cool. And B, one of the engineers was so amazed at what I did. I mean, it was like, and I'm like, I've been doing this stuff for, a decade. Anyway, it was a lot of fun. And the guy that hired me, Murray, he came over and said, gee, you guys are feeling pretty bad about this. I said, yeah, we really destroyed a lot of stuff we have to fix. And he says, just remember, if you don't blow something up now and again, it just means you're not doing anything. So I'm like, okay, I got that. So I did something. So so I did a stint at Bulova. I learned a lot. I saw timing mechanisms, all mechanical. I mean, they were basically making these mechanisms like watches. So I was also very much into cycling at the time. Me and two buddies of mine, I'll give them a shout out, Larry and Steve. The trio of us were very into cycling, and those guys were very good at it, but I enjoyed it. So the three of us had a lot of fun on the bicycles. And at one point I changed the brakes on my bicycle and I needed a bushing. And there was this old time German machinist who was working for Bulova, and he had been working in the watch portion of Bulova. And he was a really nice guy. And I went over to him. I said, gee, I don't know how to tell you what I want, but I want a bushing that goes in a hole that makes it a little smaller hole and has like a little shoulder. And we kind of sketched something out. And he says, I'll take care of you. So I go away and I come back later and he says, here you go. And I remember him putting them in my hand. It was like two of them. And it was just mild steel bushings. And I looked at them and he had a 9-inch South Bend on his bench at work. And I'm like, okay, I just told you what I wanted, and you just made it out of steel, over lunch, and I am in.
Right.
So that was the machining hook, and I'm like, okay, I really like that a lot. So
I think a lot of people get hooked by that instant gratification, or maybe not instant, but you're creating something. Quickly.
And he did it with his own hands, and it was it. I was like, okay, I got to learn about that. So let me back up now. So now there's one final story about Bulova before we get, we head off to school. But my dad was a magnificent gun stock maker. He was a magnificent craftsman. He did a lot. Everything he did really well. But he made gun stocks that were gorgeous. So let's back up. We're in an apartment in Brooklyn, and we called it a big apartment. We said, we have a big apartment, until I went back after not being there for a while, sort of one of my last visits. I realized this isn't that big. So anyway, in his lap at his desk with hand tools, he made gun stocks that were absolutely gorgeous. And what can I say? So the craftsmanship gene, absolutely came from him. And we never had a machine tool more exciting than a hand drill in the house. So when I saw that lathe, make those parts at Bulova, I was done. I was in. So the exit interview at Bulova was the boss of the department, who I respected from the standpoint that he gave me a job, but during the job, he gave me some G jobs to do for his son's band. Okay, he gave me a big audio panel to build and wire up for his son's band, and it was on company time, and I'm like, I was left unimpressed. But when it was time to go back to school, he called me into his office. Oh, let me back up a little bit. So I mentioned that I had to take the train from Coney Island, Brooklyn to Valley Stream, Long Island every day. This was take a subway to the LIRR and then switch the LIRR and take the LIRR out to Long Island and go to Valley Stream and do my thing. And this is what I was doing. So I learned how to commute. So at the end, he comes to me. At some point I got docked because I walked into the building. I was supposed to be there at, I think, 8:00, and I walked in at 8:05 because the trains were late. And he came over to me and he gave me the lecture. He said, "You come in 1 minute late, we're docking you 15 minutes pay." And
oh my goodness!
I looked at this guy, and I said, I'm going to have the last laugh, right? So, I said, "Yes, sir." And so the last week comes, and he calls me over and he says, "Listen, we really like what you've done. We'd like to offer you a position as a junior engineer." And I said, "Yeah, okay. Let me think this through. I could work here for you as a junior engineer, or I can go back to MIT. Let me think this through. Hang on, just give me a minute. How about thank you, no?" And that was the end of that. So I was very grateful for what I had. I'm not, dissing that, but that was sort of that particular character, who was illustrated by Gary Larson. Yeah. Anyway, moving on. I get back to MIT and I go to work I get a UROP. There was a thing at MIT called UROP, the Undergraduate Research Opportunities Program. And I get a UROP position with the High Altitude Balloon Research Department in the Electrical Engineering Department. And this was awesome. So I show up on the first day in this lab, and they've got, electronic bench and everything's kind of, set up, anything you need. They had a storeroom of electronics where if you need anything, you just go down and you ask for it. You put your project number on there and you got it. And it was awesome. It was like a cross between DigiKey, McMaster-Carr, and McDonald's. And it was in building 36 at MIT. And it was awesome. I think it's still there. I think they still do it. They must, but probably better. And so I get this project, and the guy I was working for, who was probably a PhD candidate, comes in and gives me this binder. And he says, "Look, we're setting up this high altitude balloon, and you're going to make the motor drive to run something we call the sun pipper." So it was like two metal plates with a very thin slot between them and a photo sensor. And this thing would rotate at a very precise rate. And they would know the precise position. And I was going to make the circuit that drove this, what I now know is a stepper motor, effectively. And I remember it was an H-bridge drive, and all the stepper heads out there know what I'm talking about. So I said, okay, and there was schematics, and I said, well, is there any other documentation besides this schematic? He said, no. Have a nice day. So that was the first, after Bulova, that was the first thing I did that I was paid for building something out of nothing. So I had to do the box. So I had to do the mechanicals. I had to do the electricals. I had to do, get everything up and running, which I did. And eventually this package, now you got to realize these guys were not fooling around. They were going to Texas with these payloads, and there was a balloon launching installation down in Texas, still there, still doing the same thing. And this payload was the size of a Volkswagen van, and it was doing X-ray astronomy. So they had to get this payload above the atmosphere, or in the high atmosphere anyway, and they were pointing it and doing X-ray astronomy with it. Yeah, super cool.
Wow.
Super cool stuff. Yeah.
I think there's a company in town that actually does that now in Tucson called Worldview, and they send balloons up all the time. So
I bet I could walk into there and find out that we're one or two connections away. Yeah. So I built this thing and they put it on the payload, and a couple of weeks go by and they tell me that it was tested, everything's working, and they're going to launch out of Texas. So they launch. And meanwhile, I'm busy with school, and by school, I mean, I was on the MIT pistol team, and the varsity pistol team was awesome, and we had a great time, and that was my social focus. So I still, to this day, I don't think a day goes by that I don't talk to one of my friends from those relationships. So it's not like I was looking for things to do. I had a lot going on, and I didn't talk to these guys for a couple of weeks. So we'll get back to the pistol team. And I get a call, hey, come on into the lab. So I get into the lab, and there are these long faces, and I'm like, what happened? They said, well, sort of a good news, bad news. The good news is the payload went up, the data was taken, it was a good run, everything was cool. And you have to picture these balloons are the size of a building, right? And he said, we gave the command to cut the balloon loose and come down on the parachute. Only the parachute never opened.
Oh, no.
So this package from 120,000 feet comes, I think the parachute folks call it streamer, right? It comes streaming through the atmosphere and it crashes.
Oh.
Now, it doesn't just crash. So the place where they launch these balloons in Texas is this huge field, right? I don't know how many acres or hundreds of acres or thousands of acres, in the middle of which is one tree.
No.
And this thing comes crashing through 120,000 feet of ever thickening atmosphere, and it finds the one tree. So this payload is not only now in a billion pieces of bent metal, but it smashes into this tree. So they literally get out the dustpans and they sweep up the results of this payload, and they put it on the truck and they truck it back to Cambridge, Massachusetts. So I come into the lab, and here's this twisted box of everything was trash. It was just totally trash. And the guy I was working for came over to me and he said, after we got back, there was only one thing on that payload that was still working. And it was your circuit.
Oh, my goodness.
So it's like, all right, I guess I am going to be an electrical engineer. So that was pretty funny. True story. Look it up. Oh, God. So I was on the MIT varsity pistol team. And usually when I tell people those words, they don't get that all those words fit together. Like, all right, first of all, varsity pistol team, that is complete cognitive dissonance.
Yeah, I didn't know that was a thing, for sure.
And then you put MIT in front of it, and nobody knows what the hell you're talking about. So no, we competed in international pistol shooting. We also had a rifle team. More on that later. And we were very, very good. And we had a very, very good coach. Pasquale Melorano, we called him Pat, was a magnificent coach, like an uncle to all of us. And he was an international competitor, very highly ranked. He was on the United States, U.S. Army Reserve Gold Team, which, if you're in the pistol shooting world, is no slouch. That's the cream of the cream. So we had awesome instruction, and we had an awesome team. And you know how these teams go, it sort of boils down to this core of people that really want to do it. And I really wanted to do it. I kind of left out that my dad, again, it came from my dad, taught me how to shoot when I was 5. And we went to the range and did target shooting, and we went hunting. And we lived in Brooklyn, New York. You have to keep that in mind. Okay, it's like what?
Yeah. Well, you said gun stock, so I figured usually guns go with that.
I was going to, yeah, right. So the pistol team was an awesome experience, and I had some fantastic teammates who shot way better than me, and I had, and we had an amazing run. So one of my teammates, who also I shared an apartment with for a while I don't remember exactly when it happened. He said, "Hey," he was a mechanical engineering major. He said, I've got to go over to the mechanical engineering lab. Oh, you know our friend Laney?
Yeah.
Help me.
Adam.
So the lab that he runs over at his school, there was a lab at MIT like that for mechanical engineering students. So if they were doing projects, they can go over, and they had this amazing machine shop with everything in it, and they could do their stuff. So my roommate's name was John. I will not give you his last name. And he said, hey, you want to come over with me? I have to go work on my project. And I said, can I run a machine? And he said, yeah, I'll set you up on a lathe and a mill. And I'm like, well, hell yes. So off we went. And it was my first time on a full-size real machine ever. I think it was the first time I ever touched a lathe, ever.
Wow.
So he showed me, A and B and C, and we found a rod of steel and showed me what to do, and I started turning this rod. Now, let me stop the story at this point, because John Saunders is just sat up in his chair, bolt upright in bed, saying, wait a minute, his first machine tool was a lathe, and he's never going to let me live this down. And I recognize that. I admit to it, because I'm open. Okay. So I start making chips on this lathe. And if you thought I was like in before, when this German machinist handed me some lathe parts, no, I was like all the way in. This was pretty awesome. But then the sky had not yet parted, and the angels have not yet sung. And then he says to me, come here, I'll show you how to run a Bridgeport. Oh my God, that was awesome. And it was just a Bridgeport. Any one of a number of years it could have been, any one of a few different models, but it was a Bridgeport. And I started crunching on some, I don't even remember what I did on the Bridgeport. I just remember it staring me in the face.
Right.
And that was the end of that. So yeah, I was in hook, line, and sinker at that point. And I didn't have a plan. I didn't know how I was going to learn more. And frankly, I was so busy with school and pistol team and life that I knew I'd eventually get back to it. So there you go. I just took you from zero to I like machine tools. And now we're somewhere in 1981-ish, maybe 82-ish, and I'm seriously digging it. Somewhere along this time, so the same roommate who took me to the mechanical engineering laboratory, one day he randomly says to me, hey, I'm going to go take this pilot ground school during IAP, which is basically the month of January, inter-session activities period, I think, or something like that.
Okay.
It's MIT. It needs an acronym.
Right.
So he says, I'm going to go take ground school. I'm like, what's ground school? He says, well, that's where you learn, the bookwork for getting your pilot's license. Now, keep in mind that up until this point, my interest in aviation has been zero. No exposure. If you asked me if I thought it was cool, I would have said yeah, but zero exposure. So he says, I said, sure. So we sign up, and I guess it was 7 nights or seven evenings or something like that. And the instructors turned out to later become good friends. And we took this ground school, and the ground school is being given by the MIT Soaring Association, also known as MITSA. And I take this ground school, and I'm learning all this stuff. It's like, wow, who knew there was all this stuff to learn? And then, of course, it was, and if you're interested, we're going out to the airfield on Saturday morning, which is what we do every Saturday, and we're going to fly gliders. And they were flying out of Mansfield, Massachusetts, Mansfield Airport. And I'm like, yes. I don't know why yes, but yes. So John and I head down, and this became yet another social circle, was the MIT Soaring Association. Long story short, I jumped in a glider with an instructor. And if you didn't think I got hooked on one side of my mouth, I was now had a hook on the other side of my mouth. And I fell in love with flying. So as if I didn't have enough to do, which at this point you're probably saying to yourself, did he ever have time for school? And the answer, dear listener, is apparently not,
Yeah.
as you will soon learn. So I started flying gliders every Saturday and Sunday. I think we flew both days. So if it was a weekend, you were at the airfield, and we're dragging around gliders, and we had, for the aviators, we had Schweitzer 233s and a Schweitzer 126, and we also had a Blanik, which was a quote high performance close quote aluminum skinned, very, for its day, it was pretty hot stuff. And we'd haul these things around the by hand, and we had a tow plane, which was a Cessna 150 with a 150 horse engine, affectionately known as a 150 150. And that little sucker did awesome work. And the Lincoln Laboratories kindly, which is a part of MIT that was based out of Hanscom Air Force Base, they kindly let us keep our tow plane in their hangar, which was really neat. So our tow pilot every morning would go to Lincoln Labs and pick up the plane and fly over to Mansfield and start the towing operations. So I sat exactly 200 feet behind this tow plane for, many flights. And I eventually got my pilot's license as a glider pilot. And that was circa 1982, 83-ish.
So just as you were about to graduate?
Graduate is a strong word. I would rather just think of it as a year. So I got my pilot's license, and so I started flying gliders very regularly. And at some point I bought a glider, which was a Grobe Aster CS, and loved that thing. And then I started flying up at Sugarbush, Vermont, which those of you who show up in Vermont in the winter think of it as a ski area. And we think of it as a glider area during the summer. And I did that for a number of years. And it's sort of there's a mix here of MIT people learning how to fly gliders, but they're also nerds. So there's some, I flew gliders with some of the, world experts in turbines, world experts in aircraft design, world experts. I mean, it's crazy. I think the guy at the time who was the world's expert in turbulence, like from a mathematical point of view, he was one of the guys in our club. I mean, and then one guy who never told you what he did ever, and it had something to do with diamonds. And yeah, we're not going down that road. So, just this eclectic group of people. And then up at Sugarbush, you could have made a movie of the shenanigans that went on up there. So I was now in aviation, and that was a lot of fun. I did that for many years. Ultimately, I had an airplane, got my airplane rating, and then I owned another airplane, and then got out of that. And actually, after selling the second airplane, I sort of stepped away from aviation for a while. So I've been airplaneless, and I get a lot of grief from it, from my fellow aviators.
Oh.
And that's something that I think, if you follow me on social media, that may not ever come through, that I'm interested in aviation, but that's sort of dormant. So I did. Yeah, again, great, met a whole bunch of super cool people, made wonderful relationships, had great experiences, and I decided to leave school.
Okay.
And I was a frustrated Ute, as we used to say in Brooklyn, and I decided I just needed to get out. So I got out and immediately started working as an engineer. Go figure. So I'm what they call a non-degreed engineer. So I left school on friendly terms. I say that because my parole officer requires me to say that. I'm a volunteer for MIT. I'm an educational counselor. I do the incoming candidate interviews. So I have a great relationship with the school still. And they like donations. Yeah. So I leave school and I start working for a company called Teradyne, which is still around. And just to be clear, so now Adam Booth just sat up in his chair and said, "Did he say Teradyne?" So the word, the name Teradyne has been used a few times, but this is the electronics company not the spray welding torch company. So, don't panic. Teradyne was a company in Boston. They made test equipment, and they gave me a job. And I worked as an electrical engineer for them, and it was awesome. And I learned so much about analog design and electronics, and that was a wonderful experience. But I also unwittingly got on the cycle of high tech boom and bust. So 4 years later, the whole. So now where are we? We're in 1980, 88 ish.
Okay. So I still
No,
have yet to hear the word antenna besides when you were doing radio in your apartment. So how did you get to that point?
Dylan, you're a brilliant observer. So don't forget, I was the guy that when my roommate said, "You want to go take a ground school?" I said, "What's that?" And now, I've owned 3 airplanes. So
Right. I'm waiting for the friend that's like, hey, you want to come play with my antennas? Like,
yeah. hang on, it's coming. So, well, let me just say that the antenna thing was a slow burn. So from my first exposure to ham radio and antennas within ham radio, I had this very slow ramp up of what the hell does an antenna do? It's like the handbook says, get a piece of wire and do this with it. And it works. But why? I don't know why. And then I said, you know what? I don't care why, because I'm interested in girls now. So, it sort of smoldered. And we haven't even gotten to the ignition yet. So it's still there. It's still in the background. So I worked for Teradyne, got laid off. That must have been, I want to say 85-ish. Maybe that's about when it was. And that was devastating from a self-image point of view, because I didn't know that happened. I didn't know. This was my first job. I remember the day my boss, Joe Rinn, what a wonderful human being. No, really, just a great guy. And Joe came to tell me about the layoff, and I swear I think he was crying.
Wow.
It was tough. So I got laid off because I was, I had the least seniority. And I went into this, I call it the dark period. It was 8 months I worked for a company that I will not mention because I did some work in the area of FCC testing. And the people I worked for were suboptimal people.
Okay.
I think I got out of that pretty good, don't you?
Yeah, that's a good way to phrase it.
We'll just let that hang. So in this period of time, I also went, I was very escapist. I went with a buddy of mine, and he said, hey, you want to go fly a glider contest down in South Carolina? South Carolina? Yeah, South Carolina. And I said, of course I do. So off we went and drove my Chevy with my glider behind it with my buddy down to South Carolina, flew a glider contest. And that was that was sort of I have got to get away from everything. And it was effective. So anyway, I get back from that. And eventually I clawed my way back up to some self-esteem and started looking for a new job in earnest. And I called a good buddy of mine, Steve, who I knew worked for this cool company. And at this point I was in networking mode, talk to everybody, right? So I talked to him and I said, hey, I'm looking for a new job. And he said, well, come talk to my company, which was a company called Analog Devices. So I did, and I got a job there, and great company, some really fantastic people, some great teachers. I learned a lot about electronics, and this was when the antenna thing really started percolating. So I was not enjoying Analog Devices, and it was because I was chasing somebody else's dream. I was doing something which I had framed many years ago as where I wanted to go, and it wasn't what I was interested in. And this thing in the back of my head was gnawing at me, this antenna thing. I started reading and studying and reading and studying throughout this period to learn about antennas. And I realized that's what I want to do, except I sucked at it. I didn't know, I didn't understand it. I didn't get it. So keep in mind, I did not approach this from the academic path, which is a valid path. I got off that train. I was reading books and studying and reading and studying, and I didn't get it, and I didn't get it, and I didn't get it. And then one day I woke up, I think it was a Wednesday, and I said, holy crap, I think I get it. And I did. It's like, I understand how antennas work now. I can speak antenna. And what's the first thing you do as soon as you get the barest understanding of a topic? You become a consultant. That's what you do. So I went out and I said, hello, I am an antenna consultant. How can I help you? And ironically, I was able to help some companies, and I started doing some stuff, and that was the beginning. And I did some interesting work for a nonprofit organization down in Cambridge that had latched on to the ham radio satellite operations as a way to solve their problem to get messages into third world countries where there was no services, but they were providing medical services. And a lot of people don't realize that ham radio operators, or ham radio in general, worldwide, had satellites, but we have since the beginning of satellites almost.
I had no idea.
Yeah. So what would happen is I'm a life member of an organization called AMSAT, the Amateur Satellite Corporation, and that's been around to push the amateur radio satellite presence from the very, very beginning. And hams are, if you look at all of the pioneers in satellite technology, you will also find a bunch of hams. So it wasn't like we had a lot of trouble, finding the technology. So they were using one of the ham satellites. No, scratch that. It wasn't a ham satellite. The University of Surrey out of the UK had designed and launched a ham satellite. I think it was UO-19 for you nerds. And then they launched its twin, UO-22, but it was designated as a non-ham satellite. And we were using that satellite, if my memory may be a little off on this, and we were doing the same thing that the hams were doing. So the satellites were low Earth orbit, so they'd come whizzing over when they came whizzing over, and you had to track them. And you were able to send and receive messages in a store and forward mode. So the satellite actually stored messages. So it was like a bulletin board system, but in orbit.
Oh, cool.
And we were interfacing with this newfangled thing called email, and we enabled email from medical professionals in the United States and around the world to non-professionals in Africa to solve medical problems. It was pretty cool. So one of the things I did there was to say, hey, well, why are you using tracking systems that are very complicated? You have to have somebody that understands what they're doing. It's very easy to get wrong. And if you get it wrong, you have no communications. So I said, let's design a system that uses an omnidirectional antenna. And it was like, oh, yeah, that doesn't work really well because we tried that. And I said, well, how'd you try that? And said, well, we use these antennas, and I won't. This isn't a DIS, but there was an on-the-market antenna, which was in the generic form of what we call an egg beater. It looks like an egg beater. And it doesn't work very well. I said, well, that's because it's the wrong tool for the job. So I actually found a military antenna. I went to the company and said, hey, would you help us out and make this antenna, but on a different band? And they said, sure, for an awful lot of money. So they did. And it worked. And it was like, here we had fixed antenna installations, and we literally were able to do triple the data rate that these egg beater antennas were doing. So that was sort of the beginning of my major successes in antennas. And it was all a party after that. So I went to consulting was difficult to make a lot of money at when you're at the level I was at and had the connections I had. So I was cold calling companies and I was looking for work, and I was met with some success. But one of my customers, one of my prospects said to me essentially, well, we have good news and bad news. And I said, what's that? Well, the good news is we like your stuff. We want you to work on these projects. I said, what's the bad news? We want to hire you full time.
Yep.
And I said, oh, I'll have to think about it. Okay. So I went to work for that company, and that was DTC Communications in Nashua. And I worked for them for 6.5 years. And that was a great time. Designed zillions of antennas. Now, I bet you think we've gotten so far afield in the world of antennas that we've forgotten our machinists that are listening intently to this podcast. But no, dear listener, here it comes. So I get to DTC and I'm doing my thing, and I walk into this kind of storeroom area behind one of the labs, or behind the lab, and there's a Bridgeport.
Your old
and
friend.
I'm like, yeah, it's like following me around. And I'm saying, I cannot believe not only will I be able to eat this week, but I have a Bridgeport. So I had an awesome time. And one thing that saddens me is one of the first big things I built while I was there was a rack mounted thing, but I jeweled the front panel of this rack mount, and I did it all on the Bridgeport. I was just having such a good time. I was there till 10 o'clock at night, and I don't have that anymore, and it's probably in a dumpster somewhere. But I kind of wish I had that hanging on the wall, because that was awesome. But I designed antennas for all sorts of applications, and I had to build everything. There was not like you didn't go over and hand it to the machinist and say, make me one of these. So I was doing all of my own prototype work. We did have a machinist that we worked with who lived down in Rhode Island. I was in Nashua, New Hampshire. He was in Rhode Island, named Buddy. He was a great old hand. Unfortunately, Buddy's probably passed by now, but great set of hands, great machinist. And he did a lot of the prototyping of chassis and very fine mechanisms. And he was a magician and was an awesome guy. But I had a Bridgeport, so, stand out of my way. So I built antennas. I built prototypes. If this was a video podcast, I would do some show and tell. But that was an awesome period of time. And at some point, I also did electronics. So this is funny. So I'm the antenna expert, but I also had to become the battery expert. So now I am the resource for antennas. So I was doing my antenna thing, but I also was the battery expert. So, mostly because nobody else wanted to do it. So I knew about batteries. I designed power supplies. I designed transmitters, and I even got into some microprocessor stuff. So
wow.
I avoided the software, but we had to design in some microprocessors. I designed one product, which may still be in use today, I don't know, which was for a government agency that was the size of a credit card. Actually, it was designed to be the size and thickness of 2 credit cards stacked up. And it was a beacon that helped investigate mail fraud.
Oh, wow.
Because people were stealing credit cards out of the mail. And this was a long time ago, so I don't think I'm speaking out of school here. And it was so in that thickness package, I designed, 3 batteries, a transmitter, an antenna, 2 microprocessors. And this thing was pretty cool. And a unique method of attaching some very fine wires that you put in the gum of the envelope of the piece of mail that you were tracking. So you could literally tell that this piece of mail was there. You could track it. You could literally direction find on it if you wanted to. And if somebody ripped it open, you immediately got an alarm signal on the same channel. And that was pretty cool, man. I was talking to companies that were doing the injection molding. So we had to design something that was going to be injection molded. And I actually designed, here's a good takeaway from that thing. We needed a motion sensor to tell if this thing was moving. So you could tell from the radio signal whether it was stationary or whether it was moving.
Oh, cool.
Well, you only have about 60 thousandths of an inch of thickness to have a sensor to do all that. Now I know what you're thinking. You're saying, well, geez, my iPhone has one of those in it. Yeah, but we have these little tiny coin cells. We were very power constrained. So I came up with this idea of a ball bearing rolling around in a cage where the floor of the cage was like a bunch of slices of pizza, and then the wall of the cage was another contact. So as the ball rolled around, it would hit different contacts, and the little PIC microprocessor would detect this, and it would say, hey, I'm moving. And when all that mayhem stopped, you would say, oh, I'm not moving. And then I designed it out of PC boards. So had 3 thin PC boards that stacked up with the ball bearing in it. And then we found out that was okay, but one ball was not as good as 2 balls.
Really?
That was a joke made for radio. So we ended up putting 2 balls, and if I had to remember, I would say those were maybe 15 thousandths diameter ball bearings. But wait, you're impressed. But wait, we had them gold plated. So we had gold plated balls in a cavity in a total of 60 thousandths of an inch, made out of a circuit board, and a circuit board. And it worked. So that was kind of fun. And the hard part was building them, but that's another story. So I said all that to say that once you find a gold-plated pair of balls and it works, you know you've arrived. That was the moral of that story. So I was doing the antennas, and I was doing mechanicals, and I was having a lot of fun. But my strength, my big thing, of course, was all the antennas. And I designed 100% of the antennas for that company for a long time, and we turned some failures into successes. We did a project for a little company you might have heard of called Disney.
Oh yeah, I think I've heard of them.
So Disney had one of their parks, which was in Orlando. I don't remember the exact name of it. It was like some smaller venue, but they had a big maze where radio-controlled cars can go through this maze, and then they had a big piece of plexiglass on top of it, and they had a bridge over it, so you could watch the cars. And then they had these booths where you would sit and you steer the car, and on a screen in front of you, you were looking out of a camera, which was in these cars. So these I don't know what size you'd call these things. They were about 14 inches long or thereabouts, and
like a shoebox or something.
Yeah, the shoebox-ish cars, maybe a little bigger. So you'd have some number of people. I think it was 5 people driving around these cars. Oh, here's a keyword. They called it telepresence.
Okay.
So if you I haven't done this, so don't blame me for what happens. But if you Google Disney telepresence car, you might find some history on it. I don't know if it still exists, but their problem was getting a radio signal from these cars with the video out of the maze onto these screens in a very high quality manner. And that's difficult because of something called multipath, which is where you have a lot of reflections of the signals, and you can get destructive interference where you get the signal reflecting off of one thing and then maybe direct from the transmitter, and they're exactly 180 degrees out of phase, and you get destructive interference. And that's called a multipath fade. Didn't think you were going to get any nerd talk out of me, did you?
I was
So
hoping.
here it is. So we had this system that did what's called diversity reception. So you'd have 5 receivers on 5 different antennas, and you'd vote every line of video. You'd pick which receive antenna you were going to use. Yeah, it was pretty cool. So all of those antennas were mine, and all of the antennas in the maze were mine. And I designed this is for the nerds, a bifilar helical antenna, which had a circularly polarized omnidirectional pattern. About 4 guys just got excited. Everybody else is like, next podcast. So
I'm just sitting here like, I've got so much research to do after this podcast.
Careful. That's a deep pit to go into. So those got hidden in the maze. Oh, so the Disney, here's a plug for Disney Imagineering. Those guys were smart. So at the time, they had mirrors in the maze, and they said, we want to put your antennas behind the mirrors. And I grabbed my suspenders and I, tweaked my mustache, and I said, well, young man, you can't put an antenna behind a mirror because the mirror is metallized, and that won't work. So 2 weeks later, I get this thing in the mail, about an 8 by 8 inch mirror. And the note was, test this. And I'm like, those fools clearly did not listen to me. Well, I'll be damned. It was a mirror, and it had no metal in it.
Wow.
And it was like, you guys are okay. You guys are okay. I didn't know how much it cost, but they solved the problem. So it had these 5 pretty cool helical antennas in the maze. And I got a story about helical antennas. And then they had my panel antennas. No, the panel antennas were also on the cars. We had to design an antenna for the cars that had specifications. It had to be this big, couldn't be higher than this because it had to fit in the car. And for the nerds, that was an antenna that I called an elevated feed disc pole. Go look that up. It doesn't exist. So anyway, it was a huge success. It worked. And so there was this rack of equipment at Disney in this installation where I designed all the antennas and all the power supplies. Go figure. So that worked out pretty awesomely. And I got to play with, a radio controlled car for a while in the lab.
That sounds like fun.
So somewhere during this period, I had to do some business in Ohio. And I was going to be in the vicinity of Columbus, Ohio. And I knew that my mentor, he didn't know he was my mentor. My hero, that's a better word. My hero, John Krause, was a professor emeritus at Ohio State University. And I wanted to meet him. So in my newfound willingness to reach out and take a chance, I dug for a phone number for Ohio State University for his department, and I called it. And I was fully expecting to have to fight my way through, 3 different secretaries to be able to talk with Professor Krause. And so I dial this number, and I have my steeled resolve that I'm going to have to fight these secretaries. And I hear this voice on the other end of the phone go, hello? And I'm like, I'm looking for a Professor Krause. And I hear, this is John Krause. And it's like, okay, we're going in. So I introduced myself. And for the ham radio guys, that's W8JK. And I know what you're thinking. You're saying, wait, you mean like the W8JK array that we learn how to build out of the handbook? Yes, the very same. So I introduced myself and I said, Dr. Krause, I'm an antenna designer and I would love to meet you. And I'm going to be in Ohio. And he said, well, you'll have to come by the house. And yeah, so that was nuts, right? So I go to Ohio and we did. We had a rental car and we followed instructions and we get to his house. And I got to meet and actually befriend John Krause who was the inventor of the helical antenna.
Wow.
So if you look on my website on antennasis.com and you go to the gallery and you look at like one of the first pictures, there's a big long helical antenna. And that was a project I did for a client. But that is a Krauss helical. And his history is awesome. I recommend you look it up, but that's a topic for another day. But it's one of my favorite stories to tell. I befriended John, and I said to him, I brought some show and tell, because you bring, that's what you do. So I brought some of my works, and I showed him some of this stuff. And he pointed to one of the antennas. He says, "I must have this for my next book." And I'm like, whoa, my head is not going to fit through that door. So I said, well, of course, Dr. Krauss, I'd be happy to do that. So I did. I gave him the data, and it appeared in the third edition of Antennas by Krauss. And he calls me up and he says, "Would you be willing to be one of the proofreaders for the book?" And I'm like, well, of course. So his partner in crime at OSU was a guy who is still teaching named Professor Ron Marhefka, another awesome guy. And so Ron and I were working on the book. And so he calls me one day, or I'm talking to him on the phone one day about whatever. And he says, "By the way, there's something I have to talk to you about." And I said, "What's that?" He says, "John hates being called professor or doctor." That's what it was. It was doctor. He hates being called Dr. Krauss. Please just call him John. And I'm like, I don't know if I could do that. So I tried. I probably failed because it's a matter of respect. I called him Dr. Krauss.
Right.
So time passes. I finish my job proofreading the book, and I send back all my, the 3-inch thick paper binders, and with all my scribbles on it, all my 7 scribbles on it, because you can only correct that which you understand. Right. And so time passes, and I get this package in the mail, and I open it up, and it's the brand new printing of the third edition of Antennas by Krauss. And for those of you who have a copy, you could follow along. So I was super excited. So I go flipping through to the patch antennas, and I found my 4-patch array, which I had given him. And there it was. And I had said, "Please just make the credit to DTC Communications, to my company. That's really, they pay me and they own the IP." So sure enough, that's exactly what they did. But I was so proud that my work ended up in Dr. Krauss's book. And I was like, couldn't be happier. Professionally, personally, I was just in a very happy place. So I was showing a buddy of mine. He comes over. "Hey, I got the book. Look. Here's the thing." He says, "Did you look in the acknowledgments? Did you get an acknowledgement?" And I said, "No, never thought of it. Didn't cross my mind." He said, look in the acknowledgments. So I go to the front of the book, and, sure enough, as it happens in a lot of textbooks, you know how good a student I was, so I read a lot of textbooks. So I go in the front, and it was a section on acknowledgments. So I go down. Of course, my last name starts with W, so I'm going down the column, and I get to the bottom, and all of a sudden, it's like hit me right in the face. And it says right there, Dr. Spencer Webb. And I'm like, okay, you got me back.
Oh my goodness.
It was the longest con I have ever seen, and it was perfectly executed. Thank you, John Krauss. So that's in the book, and there you go. So that's how Antennasis started, and that's been my thing since then. I've been doing antennas. Now let's wrap it back to some machines. And I was in my glider phase. Okay, I met at my airport. There was a mechanic, wonderful, fantastic mechanic, Mickey Ricard. He was if you Googled aircraft mechanic and looked at the images, okay, he was what you'd find in the 70s for aircraft mechanic. He went to school as an aircraft mechanics. He came out an aircraft mechanic, and to the best of my knowledge, to this very day, he is an aircraft mechanic. And he wore the same aircraft mechanic clothes every day, and he knew his stuff. I remember one day we're in the hangar with my 172, and I said, Mickey, there's a drip. There's an oil drip. And he says to me, it's an aircraft engine. It's supposed to drip. Anyway, Mickey was just awesome. So we became friends, and I was over at his house one day, and he had this workshop, the same workshop we all have, right, in our garage. And above his garage, it was like a attached barn. No, it was separate. I'm sorry. It was about 15 feet separate from his house, and his work was magnificent. So one day I'm over there. He says, come here, I want to show you something. So we go down to his basement, and he had a workbench, and on this workbench was a Sherline lathe and a Sherline mill. And he was building a little steam engine. And I looked at this. Now remember, I have touched the Bridgeport, okay? And I didn't know how I was going to solve this problem of needing the Bridgeport.
Mm-hmm.
But I was presented with a Sherline lathe and a Sherline mill, and I knew what I was looking at. And I looked at the work that he was doing on it, and I don't think it was 48 hours before that pair of machines were on their way to my to my address from Sherline. What a wonderful little piece of gear! And I bought a lathe and a mill. And I remember I was seeing some success in my consulting, and I started doing some work for a company called Lutron. They're still around, they're still big, and they're still wonderful. They make lighting products. And I designed and built a prototype using my Sherline mill. And in fact, that prototype is sitting on the table over there. But it was a prototype for an antenna, which is now the subject of a patent. So if you go look up, Spencer Webb Lutron patent, you'll find it. And the origins of that patent were built on my Sherline mill. So I had, in my basement now, I had a workbench, and that workbench was my machine shop. And it had those two machines, and I was working in aluminum and brass and some steel. And I thought those Sherline machines, which they're still selling today, were fantastic. And I not only taught my hands what machining was, but I actually did useful things. I got paid for it. So there you go. So don't ever laugh at those Sherline machines. They are awesome tools. So we turned my basement was where I did my machine shop. And eventually I got into welding, another story. And then in my attached garage, when I was living in Pelham, New Hampshire, that's where I set up the welder. And I'll tell welding stories in a second. But it was going good. And then I said to my beloved wife, she who must be obeyed and is, I said, let's build a shop. Let's build an outbuilding. So we did. And I built this magnificent shop, which I sorely miss. It was an oversized 3-car garage with 2 doors and a space above. I designed the whole thing. It had radiant heating in the slab, which was the most magnificent thing for a machine shop ever. And then upstairs was the lab and my office. So ironically, that's what we're in right now, but in a different house. I could describe the same thing. 3-car garage downstairs, upstairs, office, lab, except that it's attached. That was a detached building. So we built that detached building. And very shortly thereafter, I bought my first full-size machine, which was a jet lathe.
Oh,
So
okay.
I had the jet lathe, and pretty soon thereafter, I don't remember what order that happened in, but I got a jet lathe, 13 by 40, and I got a Bridgeport. I remember it was a 1960 61-ish vintage J1 horsepower, J head 1 horsepower Bridgeport. And that went into the new garage.
And you finally had your Bridgeport.
I had my Bridgeport. And I know where that Bridgeport, by the way, I eventually sold. I'm not sorry because I decided I'm no longer a collector of things, but I had my Bridgeport, I had my jet lathe, I still had my Shurlines, and I was in hog heaven. And that was my first real shop, was in that building.
So how do we get from this jet lathe and a Bridgeport to now you've got what, a Sharp, a TL1, you got some new incoming machinery. How do we go from one to there?
It was a total disease, complete. I had it bad. So the the first major change. So you'll notice that there's a complete absence of CNC machines, right? That has not happened yet. So one day I wake up and I said, I need a CNC machine. So I bought a Bridgeport with a Track AGE3 on it, which is a two-axis controller, and you programmed it conversationally. I had a CRT display. Now that machine still exists. That's down with my mentor, John. I haven't talked about him yet. In South Carolina. That's his
awesome.
now. I sold it to him. So that machine is still running. But that was my first CNC machine. And I started understanding how to improve my process. And I actually started doing some manufacturing. So some of my antennas I would manufacture myself and sell in quantities. So 5, 10, I think the highest production run of anything that I ever made was 80. So I made 80 special antennas for the Argos satellite system, ground stations. That was pretty cool. That was one of my patents, actually, a very broadband antenna. So I made brass parts, aluminum parts, Delrin parts. I made assembly fixtures. I soldered everything together myself. I learned how to interface with anodizing, plating and anodizing houses. I learned how to interface with painting and graphics houses. That was I loved that project. That was just awesome. I learned what it meant to build a fixture, because, hey, I'm going to be making 80 of these things. I need a fixture. So I started designing fixtures and building the fixtures, and that was all done in my shop. So that was a really good example of a project that went from soup to nuts, including the patent and ownership of the IP and shipping the product out the door, all inside of my four walls. And that was the coolest thing. And that project, so I had the Track AGE3, and then now a whole separate bug to bite me was CNC, right?
Of course.
And it's like, okay, here we go again. I'm in. So we started upping that game. So I think the next machine was, I believe the next machine was upgrading the Bridgeport with the Track AGE on it to, which is a Southwest Industries control, to give them credit. I sold that and I bought a bed mill. So this was this is a very funny story. This was a Southwest Industries machine that had, this big, it's like you're looking at a Bridgeport head, except you just honey I shrunk the machinist, and it's big. And it was a 52-inch table. God, I missed that machine. It was awesome. And the story behind that machine, and it had a Fagor control on it.
Okay.
So I said and I bought it from Rice Machinery. Rice Machinery is in Rhode Island. They deserve a shout out. Always been really super nice to deal with. Happy to pay the price on all the machines I bought from them. And I bought 1, 2, 3. I think I've made 3 purchases from them. And I said, okay, I get the Fagor control. What's the story behind this machine? And he says, well, the owner, originally bought a Southwest Industries, I forget what they call it, machine, and they hated the controls so much that they hired us to rip the track control off it and put a Fagor on it.
Wow.
So that was, I am not commenting on, whether or not I would have agreed with that particular customer, but that's what happened. So here's this Fagor control. So I get this big machine, big bed mill. That was a great machine. Oh, and the other part of the story is that machine came out of a company somewhere in New England that made sequins. So what the hell's a sequin? So a sequin is a little flashy piece of metal you sew on a dress,
Right.
In the hundreds or thousands. Those are sequins. I say that because there may be people that have never heard the word, but that's what a sequin is.
Well, so I'm just trying to put two and two together, like how you use a bed mill to make sequins.
I don't exactly know, okay? But I was the beneficiary because they used a vacuum table. And this vacuum table was on the bed of this mill, or the table of this mill, forever. And so when that vacuum table came off and I bought this mill, it was perfect.
Wow.
So not only was it perfect, but they used the entire range of motion of the table. So this thing was like nowhere.
Right.
And it was a great machine. Oh, this big bed mill becomes my big CNC machine. And I start making stuff. And I make a lot of parts out of Delrin as an insulative material in the world of antennas, and it's good mechanical properties. So the floor around my bed mill and actually my entire shop now looks like there was a snowstorm. So I put up these curtains around the machine, and that was my enclosure. Of course, the operator's inside. So this bed mill turned out all sorts of work. It was a very productive machine. At which point I kind of stared over, looked across the shop, and my jet lathe was kind of looking at me. And I was looking at it, and I said, yeah, you have to become a CNC machine. So I was at East Tech, which a trade show which I tried to attend regularly, but fail. And of course, we're just emerging out of COVID times, so we had that. So I haven't been to an East Tech in a couple of years, but I went to East Tech, and one of my very specific requirements was I want to find a CNC lathe. And I wanted a big enough hole down the bore so that I could do rifle barrels.
Oh, okay.
Because I figured I don't have enough hobbies. And I looked at a few things. And I looked at the Southwest Industries offering for a tool room style CNC machine. And I looked at Haas, and I looked at the Haas TL1. And I probably looked at a couple other things. But I bought the Haas TL1. And in fact, the machine, which was on the floor being a demo machine, was my machine. I ended up buying that machine.
Oh, cool.
And the TL1 is still downstairs. It's about 20 feet away diagonally from me right now. And that's been an awesome machine. I could tell, I will tell some Haas TL1 stories. I had a company, a big defense contractor, come to me at some point and say, hey, our PhD R&D guys need some help. And I said, well, what's that? They said, well, they're doing stuff up at the hundreds of gigahertz, and they need a reflector antenna to feed their sensor. So they have the sensor, but we need the reflectors made and everything. I said, sure, I'll come in and talk. So I come in and go in to see these guys, and I meet with this PhD, and I'm all excited now because, hey, there's all sorts of machining that's going to happen here, And I said, so, what do you have? And he slides a piece of paper across the table to me, which is a PowerPoint slide that was clearly printed. And on it was two equations. And I said, okay, what else you got?
Right.
And he's like, no, he's all excited, right? Because he does like to get called doctor. And he says, those are the curvatures for a Cassegrain reflector antenna has a main reflector and a sub-reflector. And there's a big hole in the main reflector. And if you're on my website, if you go to antennasis.com and you go to the gallery again, or if you go to Kinetic Precision, actually it's the front page, you'll see a picture of this thing. So he says that those are the curvatures that we need to feed our sensor. And they had zero, and I mean zero knowledge of how the mechanicals are going to work. So I got the opportunity, and I was very happy to have the opportunity to do all of the design work and explain to them what they needed to do and how they needed to mount it and all that kind of stuff. So that reflector antenna that you see in that picture, the main reflector is 15-inch diameter, and that surface had to be held to better than 2000s everywhere.
Wow.
I guess today we'd say, absolute position. So, I don't know any better. I said, of course I could do that. So that was a project that ended up on the TL1, and the back of that antenna is cleverly designed to look like a chuck. So it has a big hole on the back. And so I was able to take a standard adapter plate and mount that on the back of the chuck after it came off the mill, of course, and finish the face and the hole of that main reflector. And you know what happened? We held 2000s all over all day long. Thank you very much. It came off the lathe. Nothing ever had to touch it. It was done. And that was magnificent. So the TL1 came into the shop. I jumped ahead in time, but the TL1 came in the shop, and that became my first CNC lathe. And for John Saunders, let me just say that again. Lathe. He's redeemed himself. He actually likes lathes now. # I love lathe. So that was the next machine that came in. And then time passed, success was happening, and I decided, okay, I need to go full size. I put that in air quotes because I didn't know then what I know now. But I needed a full-size vertical machining center, and I ended up buying a Sharp SV 2412S, and I bought that from Rice Machinery. I bought it brand new, and then for consideration, I let them take it to East Tech. Well, there's East Tech again. So I actually visited my machine at East Tech before it was in my shop. But that came in, and that was my schooling on, vertical machining centers. And that was a lot of fun.
Those are good machines. Those are really good. Those are really good machines. My business partner, his day job had 5 or 6 of them, and I've only started replacing them recently because they've just been beat into the ground over years of newbies running them and that kind of stuff.
Well, I don't want to brag, but mine has about 2,500 hours on it. So I know how to wear out a machine, trust me. But they're all me, right? It's all 100% of it is me. So that's how I learned about vertical machining centers, by buying one. And a little plug: the control is a Fanuc YMC on the Sharp, and I had an early failure. I guess this was one of the machines that used fiber optics to talk between their boxes. I guess it was one of the first ones, allegedly. But I had a failure, and the letters FSSB stick in my head, but there was some box in the back, right? So I called up, and they flew a guy out. I guess this is how they work, from somewhere, Chicago or whatever, wearing the yellow underwear, and he came in and he did a box swap, and I was back up on the air, and it was no charge because it was all under warranty.
Right.
But the word I use for Fanuc is bulletproof.
Yeah.
It's absolutely bulletproof.
Well,
so
and
now,
you were talking about Bulova being behind the times because it had to be bulletproof, and I feel like Fanuc or Fanuc, however you want to pronounce it, is the same thing. They're definitely not ahead of the time, but they are bulletproof.
I completely and totally agree. That's exactly correct. And that's leading us to, I know we're the latest machine, which we'll get to, also has a Fanuc controller on it, and that was part of that decision. So the Sharp's been magnificent. It's done all sorts of things. So that that Cassegrain reflector antenna started as a 42-pound block of aluminum, started in the mill, went to the bandsaw, then it went to the lathe, and then the main reflector was done. The subreflector on that was 100% lathe part. And then the spider on that was the same thing. It was mill part that went to the lathe for threads. So between the TL1 and the Sharp, which I still own now, in fact, those are my machines, they've done some magnificent work and hold tolerances. They're well within tolerance all day long. So that kind of brings you up to where the shop where the shop is, except for we moved towns. So I moved from Pelham to Windham, which is one town north, and bought a house that was already built, 3-car garage, space above, attached, but in a neighborhood appropriate for kids. So, educational system, kids, blah blah blah. What a weird space I'm in, though. I have a 3-car garage with 13-foot ceilings.
Wow.
So, whereas in the old place I had normal ceilings, whatever the heck they were, 9 feet or whatever I designed, I don't remember. But we also had an attic space. So we had attic space for storage, etc. So we have no attic space for storage in this building and 13-foot ceilings. So I have a big pallet rack in the corner and a ladder strapped to it. So I try to go vertical on everything.
Oh yeah.
And now we have one of these hanging shelves off the ceiling again for storage. So it's a constant battle of anything that can be stored up, we store up. So when we got here, I recognized that my manual Bridgeport, was clapped out, and I was having to struggle with it. At one point in my history, I'm taking this out of the timeline, I attended a scraping course with Richard King. What a great experience. Also hosted at Saunders Machine Works. And that was a lot of fun. That was just a hoot. And that got me, if not into scraping, I put that in air quotes, it got me understanding of scraping and competent. I was competent. So if I have to do something, I can do it. But there are others that are much more competent than I in actually rebuilding machines. So I
was
stick that in.
Kind of your first slow burn of flat? Is this where that whole thing maybe started?
You're a brilliant man. Yeah. The whole consciousness of metrology and flat and ultimates and standards, and that was starting to ramp up. I don't know if you see a pattern here on a slow burn. And when I, took the scraping course, I felt pretty fancy because I already owned a surface plate. Well, welcome aboard, sailor. Now you get to learn how to use it. So I'll jump to that in a minute, but let me finish up with the Bridgeport. So the Bridgeport was clapped out. I sold the Bridgeport, and I bought from Rice Machinery a rebuilt Bridgeport that had a ground and flaked table, and everything worked. It was just solid. And I said, thank you very much. So I took my proceeds from the clapped out Bridgeport, added my, another pound of flesh, and I still have that manual Bridgeport, which is a 19, I want to say it's an 81-ish. It does a great job. So there's still a manual Bridgeport in the shop. So yeah, we might as well talk about that. So I attended the scraping course and learned all sorts of new skills, which I loved. I just ate it up. Plus I had more time to hang out with John, and that was a lot of fun. And we did it in his shop. He couldn't do that today. He couldn't host that class today because he's filled up all that room with machines.
Yeah.
How dare he?
Exactly.
But that was a lot of fun. And yes, that's when flat started happening. And at some time in there, I was like the rest of us. I was watching all the YouTube videos, and I had my favorites, and I watched anything that Robin Renzetti published. I know that comes as a shock to you because in our world, he's so obscure and unknown. And but no, I know a good set of hands when I see one, and boy howdy, Robin was on it. And so I watched, and I still watch, and when I say watch, I mean study anything that he publishes, anything that Ox Tools publishes. Tom Lipton is brilliant. So back before there was a YouTube, this is hard to believe, I followed this guy on a forum called Practical Machinist. I was a regular on Practical Machinist, and there was this guy named A-Bomb79. And, he shows up one day and he posts, hey, this is a picture of this big lathe that we have, we're starting our shop here, and my dad got this big lathe. And that was the first post that a certain Adam Booth ever made to social media. And I followed him from that day. He's what a great story. What a great teacher. But also what a great willingness to share plainly, his path in machining.
Definitely.
So that was an awesome, and still, so if he publishes a video, I watch it. And let me tell you, I can't wait to build my smoker because I think my whole life was leading to this. I now know how to weld. Okay. I recently bought a plasma cutter. I didn't mention that before, but that, there's a smoker in my future. So
it sounds like it for sure.
Yeah. So I watched this video from Robin Renzetti on precision flat ground. No, he calls them precision ground flat stones. And I was like, how come nobody ever told me this before? Why has the universe been conspiring to hide this information from me? So I got it. And I said, well, there's only one logical thing to do. So I went to my yellow catalog, or at least my online yellow catalog, and I ordered everything I needed. So I had a surface grinder. Somewhere in my story, I decided to get into surface grinding, and I got a Harrig 612 manual machine from Rice Machinery. Actually, I think that's the fourth machine I bought from Rice Machinery. Used, but well loved, rebuilt. And I put that in quotes also because it was in pretty good condition. And that was my first grinder. So I had started grinding, and I started learning how to grind. So let me back up. So before there was a Robin Renzetti, there was a John Moore. John Moore is a good friend of mine. He's down in South Carolina. John worked for Polaroid as a master machinist and toolmaker for forever. He retired out of Polaroid, and in his retirement, I should point out that Polaroid was in Cambridge, Massachusetts, and John was the coach of the rifle team.
Oh, okay.
Now we're tying it all together.
Yep.
Okay. So John was, again, golden fingers, man. He could make anything with anything. The work that he brought for show and tell was glorious. John told a story once of working on, there was a camera that Polaroid made, I feel like an old guy now, called the SX70. And the SX70 used these film packs that had instant developing film and batteries all in one pack. Well, the battery was, every single thing about that camera was groundbreaking. There was nothing about that camera that wasn't an invention. And John was in the middle of all this. He was building them. He was building the prototypes. He was building the tooling. He was building the machines that made the batteries. Polaroid did all that stuff, and it was bleeding edge. So John tells me about the first prototype they made, and they had to break all the rules. They had to invent everything. And they had this big company meeting, and Edwin Land, who was the founder of Polaroid, came to look at, to celebrate this progress. And the camera was about, 4.5 by 7 inches or something, and about 2 inches thick. And it unfolded, and then you would take a picture with it, and it would shoot the picture out the bottom. And kids these days, have filters to make pictures look like old Polaroids, right? I was like, dude, they were actually old Polaroids. So Edwin Land, and I'm telling a story from a story, right? But Edwin Land comes to this company meeting, and they have this big celebration, and they show the prototype, and they demonstrate the prototype. Everybody's happy, and Edwin Land comes to the podium, and he says, "Now make it 1 inch thick." and he walks off the stage. So they're like, seriously? So that, they got their marching orders. So they had to go and cut the thickness of this prototype in half. And you know what? They did.
Uh-huh.
And if you go Google it, Polaroid SX70 in that really sexy fold open stainless steel housing, and they invented everything. There was nothing in there that you could get off the shelf. Anyway, back to my friend John Moore. He was in the middle of that, and they sent him off at some point to a little company called Moore Precision or Moore Special Tools down in Connecticut. By the way, those are two different Moores. He spells his name Mooar, not Moore. So there's no connection there.
Okay.
But he goes down, and they sent him to grinding school at Moore Special Tools.
Wow.
Yeah, I think you're getting it, because John ground the molds for the lenses for the Polaroid cameras.
Holy cow.
So at the time, I remember he told me this, the curvature of the lens surfaces was defined by a 25th order polynomial. Now, about 20 people out there just said bullshit. Okay. I'm just reporting the news. But, you had some engineer who designed these magnificent lenses to be molded out of plastic. And at the time, they were the best performing lenses on the planet of any material. Like, they were, because you could make the curvature whatever you wanted. And if John did his job making the molds, you were popping out these lenses that were not only magnificent, they were cheaper than dirt.
Right.
So that's all Polaroid. Like I said, everything was invented. So, here's my friend, and awesome shooter, awesome rifle shooter, John Moore, to this day. And he was a tool maker par excellence, and he was available to at least advise me, if not teach me firsthand. So what do? I do what everybody does. I go buy a grinder and say, look, I'm a grinder hand, right? It's like, no, not really. You have a little ways to go. So I would go to the shop and I'd make a smoky burnt mess, and I'd call John and say, what the hell am I doing wrong? And he would tell me, and I'd go back and I'd do what he told me to do. And suddenly things would start working until I, gouged something and made a, unholy, surface that looked like, the sands of the Sahara. Call him back. John, what am I doing? So that's how I learned how to grind, is by grinding and then failing and then going back to John and like bringing myself up to speed. So now we're in the right frame of mind for Robin's video to show up. And of course I followed all his videos. A lot of them had grinding in it and I was paying close attention, but here comes this video, precision flat ground stones. And I'm like, whoa, you can do that? So I order a diamond wheel, and I order the stones, and I order, all this stuff, and they all show up. And I'm like, here we go. I'm going to do what Robin just taught me how to do, except I didn't. Except I didn't touch it for months and months. And one of the stumbling blocks was the work holding.
Oh yeah.
And I couldn't find the fingery things. And then I said, well, I'm going to make the fingery things. And I bought the stuff, and then I didn't. And then I sort of had this stumbling block. So every project has a stumbling block. And this is the old guy philosophy here, is that you'll put it aside because of this stumbling block. And if you just try something, even if it doesn't work well. So that's what I did. I tried something, even if it didn't work well. And I had a vise. I said, damn it, I'm just going to hold the freaking stone in the vise and grind, baby. And I did. And you know what? It was unbelievable.
Really?
Yeah. So I made I did my first grind, and I tried these things out. And today, obviously I have a different eye than what I had then, but I'll be damned. This not only worked, it's useful. And it, as promised, thank you very much. So I started making these things. I started getting better at them. And I took that first set, and you can go back in my Instagram history to about 2000 and yeah, I don't want to guess, but it's in there. And I posted a picture. Oh, so I make the stones and I look at them and go, well, you need a way to hold the stones. So I designed a dual tray to hold the two stones. And I'm like, this makes sense to me because I could pick up one stone and I could rub it on the other stone like you're supposed to. And it stays in the tray and they stay clean and, organized and all that kind of stuff. And then one day I figured out if you have the coarse, and I put coarse in quotations, if you have the coarse side up on one and the fine side up on the other, whichever one you grab, you get the bottom side. It's like I thought I discovered America. So I build this tray on my 3D printer. And I post a picture. I said, hey, I made my first set of stones and ain't it great? And 7 guys said to me, are you selling those? Now, life lesson, okay? When 7 people ask you if you're selling something, there is exactly one correct answer.
Of course.
Yes.
Yeah.
Of course. Yes, I am. Funny you should mention it. And I identified a market, a need. And I said, yeah, let's go. So that was the beginning of my precision stone business. And then one day I said, well, we need to call these things something. So of course you always have to look for the acronym, right?
Mm-hmm.
Oh, I'll call them PGF stones. Like, that's, and then it hit me, right? No, they're PFG.
Right.
And that was it. It's like, lightning bolt. And from that moment on, they were PFG stones. And we have a lot of fun with that name. And I started making them, and I started making them badly. So let me explain what I mean by that, okay? Everything worth doing is worth doing badly. And that's what I started doing. Now, were they bad? No, they were fine. But if you took me and you and I walked into a TARDIS and we went back in time and we went to, put on Groucho glasses so we didn't screw up the timeline, and we looked at what I made, would I accept that today? Would I let that out my door today? And the answer is no.
Right.
That's actually a little hard to admit because those very stones, I am certain, are still doing their job, right? And the guy listening to this that ordered, set number 4 is looking at me going, well, geez, if these aren't good. No, they're great. They do the job. But my QC today would not accept it.
Yeah.
Which
it's continual improvement. So
absolutely. And it was difficult improvement. That was a hard climb. And I remember one day I messaged Robin. I said, are you open to having a phone conversation? Oh, sure. Another life lesson. When a guy who's an expert in his field says, I'm happy to talk to you, talk to him. Mm-hmm. So I got on the phone with Robin, first of a number of phone calls since then. And I kind of cried into my beer. I'm like, I'm doing A, I'm doing B, I'm doing C. And he said, yeah, you're not controlling your wheel surface. And you really ought to switch to a metal bond wheel. And I'm like, yes, sir. When again, like if this story sounds familiar, when your mentor says something, you say, yes, sir. Mm-hmm. So I went and bought a metal bond wheel from great company, a CDT, Continental Diamond Tool. What a wonderful company to deal with. And I called them up, and I said, gee, I got to do this. I got to do that. Help me spec out a wheel. So they did. And I said, now how much will that be, sir? Oh, we'll send you a quote. I said, well, just give me a ballpark. I said, oh, it's probably around $500. And I was like,
yep.
Okay. I'm in it to win it, sir.
Right.
So I coughed up my $500 And yeah, it was the right thing. And then I had to learn how to true and dress a diamond, a metal bond diamond wheel. Boy, howdy, that was another wonderful education. So that led me to, we started with the mild steel technique, which you just grind some mild steel, and you read the tea leaves, and eventually the wheel will true itself because the steel will knock diamonds out. Well, I'm here to tell you that if you're on a desert island with nothing but a piece of steel and a diamond wheel, that's fine. But it's good that you're on a desert island because you're going to need a while. It's a little tricky. It can be done. Absolutely, yes. So then I learned the quote right way to do it with a Norton brake controlled dressing device, which is that funny little aluminum oxide wheel with a centrifugal brake. And I learned that, well, the whole purpose behind that is to slow the effective wheel speed down so that it will actually true the diamond wheel. So here's the analogy. If you stand there with a baseball bat, I want you to imagine that you're holding a bat in maybe the bunting position, and I gently toss you a 45 caliber bullet, you could knock that bullet 20 feet away, right? But if I shoot that bullet at that baseball bat, it's going through. So if you go to take a diamond wheel and you try to, let's say, grind a piece of aluminum oxide, like a dressing stick or something, it's going to grind the dressing stick. Thank you very much. It wins. I'm
Right.
diamond, and I'm going 7,000 surface feet per minute. Nobody wins. But if you slow it down, you get to this point, there's an optimum where the thing you're grinding can suck the diamonds out of the wheel. Okay, it's like if you were wearing galoshes. Does anybody actually wear galoshes? I just like saying the word galoshes. So if you're wearing galoshes and you go across a mud puddle, and that mud puddle sucks your galoshes off, is it because the mud puddle was harder than your galoshes? No, it's because it sucked your galoshes off.
Right.
So that's what truing a diamond wheel is about, because it's diamond. You're not abrading it. You're literally knocking them out of position. So the Norton brake controlled truing device, I did all this math another time, so I don't remember what it is, but it basically slows down the effective surface speed of the wheel to the point where the aluminum oxide wheel is in part knocking diamonds out of the wheel. And that's how it gets to true it. Well, hallelujah. Now we have a little purchase on how to actually true a wheel. So, and let me take this opportunity to say that the word truing and the word dressing are different. So especially in the world of diamond wheels, either resin or metal bond, either one, doesn't matter. You have these really hard things being held by some really soft things, right? So in one case, it's nickel, or some other metal alloy. In another case, it's resin, and the common one is resin. So you do this truing operation. You do a truing operation where you're knocking the diamonds out to true the wheel to round. But now you have to come in and sort of scoop away some of the resin to expose the diamond so it can do its job properly. That's called dressing. So now you come in with a dressing stick, which is a stick of aluminum oxide, and you jam it into by the way, this is more fun than anybody is willing to admit. And you jam that sucker into the wheel, and you use up a lot of it. So, and what that does is it abrades the resin or other matrix, and it exposes the diamonds. So I started doing that, and that started like, hey, I'm getting really good performance now. Except I dug up an old YouTube video. You could find it from Norton on how to dress a diamond wheel. And they showed the brake controlled dresser, and then the guy says, and this is a dressing stick, and I'm like, yeah, I know all this, and he says, and this is how you should dress it wet so it doesn't get all you don't put all that in the air, and I'm like, yeah, I know all that, and he says, and you should be using 1/2 to 3/4 of the stick per dressing, and I'm like, holy crap! so right, this had to be a video from the 70s. And I watched, and of course it was originally 16 millimeter film. Somebody had the good common sense to transfer it to video. Now it's on YouTube, and I'm like, oh no, you really have to go to town with these things. So that was the next step, was learning how to use the dressing stick. And finally, I felt I had arrived at I could use a diamond wheel on a grinder, and I know how to true it, and I know how to dress it. It still takes a while. It's not like a regular grinding wheel where you zip, 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 and you're done. But I started having control, and that was the magic that started giving me results on my stones that I liked.
Okay.
So time passes, and molybdenum came up. So I think I heard it from Robin first, but there was a technique, old grinder hands kept a piece of molybdenum in their toolbox, and they'd hold it in a vise and use that for truing a diamond wheel. And I'm like, oh, that's interesting. So I research it, and it turns out there's a 1973 patent on that process. And this dude, and I really ought to have the name on it. It starts with a W. I don't want to get it wrong, but I've posted about it. It's in one of my posts. He invented this. So he had a 20-year monopoly on the process, the method of truing a diamond wheel with molybdenum. The catch is, and again, you have to read the patent. The catch is, and tell me if this sounds familiar, you have to slow down the surface feet between the wheel and the molybdenum.
Huh.
Okay. Again, if I give you your galoshes and I send you to run across that mud puddle, you'll probably get across the mud puddle. But if I said you to walk across that mud puddle, that puddle's going to suck off one of your galoshes. Okay. So here's the numbers for a 7.5 inch or 7-inch wheel. It's 1200 RPM. So a normal wheel is running 3600 RPM. If you want to use the molybdenum trick, the magic number is 1200 RPM. Now, Robin teaches in one of his videos that you can turn off your spindle and then run the molybdenum across your wheel as it's naturally slowing down. And that works. And that's sort of the poor man's VFD, right? It's like, just turn it off.
Right.
So that works. But if you have the ability to change your wheel speed, you just slow it down. Now, the old grinder hand with the piece of molybdenum in his toolbox, that's what he's going to do. Fortunately, on my grinder, we haven't even gotten to that story yet. I have a VFD, so I can actually dial it down and do the dressing, and that's how I do it. And I've posted on Instagram pictures of my little molybdenum holder, and I just dial up 1200 and I go. And the other number you need to know is that it's 2,000ths depth per pass, which is, in the grinding world, that's pretty healthy. But again, the molybdenum is the mud puddle. Okay. And you've slowed down the galoshes, and you want the ones that are sticking out to get sucked off. And
right.
that's how you do it with molybdenum dressing. And it's pretty cool. So going back to my first grinder, that was the Harrig, I started making stones. And as I previously pointed out, when 7 guys say they want them, you ship it to them. So that took off, and I started making stones and really working on the process. I mean, I tried things that did not work. Okay. Put it that way. At some point, I blamed some of the loss of control on the oil in the stone. I wanted it dry because I felt it would grind better. So I had one batch where we ultrasonically removed the oil. We basically cleaned the stones before grinding. It didn't hurt, but it also didn't help. And it also cosmetically was a negative because you got kind of a halo around the stone from where it got really super dry. But I did learn a few things. See, it wasn't a total loss. One of the things is that oil that they impregnate the stones with is not oil. It's grease.
Oh, really?
So when we ultrasonically removed it and scooped it out of there, at room temperature, it was the consistency of toothpaste.
Oh, okay.
So it was not an oil. I think we would call it a grease. Maybe we would call it a super high. I don't know. Whatever. It was a good lesson, and it led nowhere. So hey, thank you, science. Doesn't work. On to the next thing. So that was a continuous process. So at one point, and I'll just put this bluntly, my left arm fell off. Driving that grinder manually was getting old and fast. So one of our Instagram friends in the machinist community put up for sale a Micromaster grinder, a Brown & Sharp 618 Micromaster. And I had been lusting after Micromasters. I kind of had them on my radar. And I said, ooh, should I? Shouldn't I? Should I? Shouldn't I? And right about then, one of the other members of our community said, I'll take it.
Oh.
And I was like, oh, okay. That was I learned my lesson. So time passes, and not that much time, a couple of months. And this other gentleman who's in Ohio was having to have a sell-off for his personal reasons. And I had already told him, if you ever want to sell that, you let me know. Well, guess what he did? He let me know.
Mm-hmm.
And he sent me a private message, and he said, if you want this, it's this many dollars, come and get it. And I said, yes. And I figured that, I'll figure the rest out later. So my rigger, the guy who did all my rigging, and by the way, in the New England area, that is Interstate Rigging, highest recommendation I could possibly give. The owner is Ed Wallace, top shelf. Interstate Rigging in New England. Was that a commercial? I don't know if that was. So I call up Ed and I said, Ed, I got a grinder. I got to get it. It's in Ohio. I don't know what to do. He says, don't worry. I got my guy. So he has a trucker that he works with who knows how to move machinery. So that guy went, picked up the grinder, and I had a new grinder. So my old Harrig, my beloved Harrig, went to my buddy Ducky, Tim Mallard, who's also on Instagram. Check it out. In fact, if you're a really super good Instagram sleuth, you will find a recent picture of my old Harrig in his basement, and he does great work with it. So the Micromaster came in, and I now had something to save my shoulder. And that's how the Micromaster came to be. But I later figured out as I cleaned the Micromaster and fixed things and replaced, metering valves and basically got it to as good as it can be, I found out that was one hell of a piece of iron, and it was in super condition. And the lesson I got from that was that it was miswired.
Really?
So the coolant pump, the hydraulic pump, they were wired 440, which is what they were when they left the factory. The spindle had a huge 1980 VFD attached to the side of it. Pictures, see my feed. And that was correctly wired 220. Three-phase. Everything's three-phase. So the first time I go to use the grinder, I engage the table feed, and I'm able to lug the table and lug the motor. I'm like the hydraulic motor, and I'm like, oh, crap! This thing needs a new motor, needs a new hydraulic pump. This thing's dead, and I was feeling pretty blue. And when the previous owner said to me, "Yeah, we only used it to make a few things," it's like, oh, this is why it's broken. It's broke. The thing's broke. So I was kind of bummed. But I'm like, okay, I still have a grinder, so I'm not going to get too bummed. I'll figure it out. And I wake up one day and I realize, wait a minute. What would happen if that thing was still wired 440? Well, sure enough, I got into the pecker box of the hydraulic motor, and it was still wired 440.
Yep.
And I changed it to 220 and the coolant pump to 220, And boom, everything was exactly the way Brown and Sharp wanted it to be. And it was magnificent. So between that and getting the oil correct and getting all the metering valves working and tweaked, and once it had lube, once it had hydraulic pressure, I was transported back to 1983, and it was a happy grinder. So a little Micromaster history, that those castings were marked 1983.
Mm-hmm.
The VFD was full of markings for 1980.
Oh, wow.
So somebody took a VFD made in 1980 and married it to this grinder, which was made probably in 83 or 80, maybe even 84. I don't know the story, but Tanda Madison, another one of our Instagram machinists, has its twin. She's down in Texas, and she sent me pictures, and I'm like, yeah, you have the twin. And she actually wants to get rid of it, by the way. If anybody wants I haven't seen that grinder in particular, but a Micromaster 618, go get it. So I got all that working. And then I started continuing to improve the process. And I started looking at the VFD and how it drove the motor. And I had this theory that the VFD was imparting some finish
Okay.
to the spindle. It was a weak theory, but it was a theory. So I got out my electronics gear and I started looking at what was going on, and actually got a current probe, and I was measuring the current probe go into the motor. So as we know, current is torque. Full stop. So it was horrible. There was not a sine wave to be found. So this 1980 VFD was a bang bang controller. It was hard positive, off, or hard negative. And boy, howdy, there's a sine wave in there somewhere, and hopefully your motor can find it. So I said, okay, and again, I posted about this. I said, okay, this sucks. We're going to improve this. So I ended up pulling out the VFD, which was, 18 inches wide by 24 inches high on a big metal mounting plate, and putting in a modern VFD from a buddy of mine helped me out. And Adam Brunette, who is also MHM Machine Works, he had one kicking around, and it worked great. And we were in the modern world. So now we're running on a modern VFD. The waveforms got better, and I don't think I can conclusively say that I improved the grind, but I would like to believe I did. How's that? So I started cranking out stones, and basically around here, if it's Sunday, Dad's in the shop, making stones. And the table feed saved my shoulder, but I wasn't satisfied with the cross feed, or the in feed, we would say. So I had some processes I do automatically, some processes I do mechanically. So the last step of my process is I said mechanically, I mean manually, is a manual process. I in feed manually, and that was getting old. So I saved my left arm, but now my right arm needed saving. So between that and other products coming down the pipe, I decided it's time. It's paid for, and I'm going to buy me a grinder. So I went looking for a CNC grinder. And a little shout out to my friends at Haas. You don't make a CNC grinder. I just want to point that out because I checked. I went all through your site, and there's no CNC grinder. I just want to point that out, Haas. Are you listening? Okay. There, that message was delivered. So there's a few CNC grinders out there, and I settled on the Okamoto. That's called an ACC 818NC. I looked at a few different ones. That gives me a 8x20 chuck. That gives me a Fanuc OIMD control, which I was very familiar with, and a grinder with an excellent reputation. apparently Okamoto owns a factory in Thailand, and that's where they're made. So I got in my car and I drove down to Okamoto's office in Connecticut, and I met with Bill Pewty, and nice guy, and we spent a day down there. This is at the height of COVID, right? So we're both wearing masks, and there's nobody else in the building. It's me and him and his entire, floor. And there was that grinder was sitting on the floor. There was no other. He didn't have any other grinders set up. It was just that one. So I got to kick the tires, and we made it work. And I, poked around and convinced myself that, yeah, this was it. But now to further tie my story together, I sneak around the back and I move the table over and I get on my knees. And you know what I did? I looked at the scraping.
Mm.
Okay. And I poked at the scraping and I said, it is good. Okay. Now, the lesson there is, had I not taken the scraping course with Richard King, I wouldn't know what I was looking at.
Right.
But I actually did know what I was looking at. And it was sweet. And I've seen some, other machines I've looked at. I won't name names. I've looked at the scraping and it made me want to puke.
Oh.
Look at any of the Chinese stuff.
Oh,
and, thank you, Richard, because I could read scraping. I know what I'm looking at. And it was good. I liked it. So I wrote a check, and Bill was smiling at the end of the writing of the check. So unfortunately, that was months ago, and too many months ago. And COVID affected things, and we're way behind schedule. That grinder was supposed to be in the shop making work, making money, but it's not here yet. And the grinder itself is in Chicago and is checked out and blessed and ready to come. But the chuck, as of this recording, the chuck and the coolant tank have not arrived. Now,
no.
Yeah. So here I am. I'm like, a chuck and a cooling tank. So as soon as they show up, and as soon as the guys at Okamoto outgoing, check the check boxes, we'll be in business. So fortunately, my old grinder is going to a good buddy down the street, literally 5 miles away.
Awesome.
And he's very excited to get it. And I'm very excited to help get him set up on it, because he's getting a hell of a grinder. And at some point I was feeling guilty, like, gee, I should really check this thing out, like put the indicators on everything and completely characterize it before I sell it. But I ended up making an offset plate, which I posted to Instagram, full size, 6x18 offset plate. And when I was all done grinding it, it went on the table, and I measured that sucker, and it was dead nuts.
Was that the one you were ring relieving?
Yes, that's right. Yeah. So Robin, I forget how Robin sent me the message. It was either a DM or a comment or something, but he talked about mechanically relieving it by ringing it. And I had heard and seen, that before. And quite frankly, I saw it at the Richard King scraping course, and he talked about that guys did this. And I'm like, come on. I can't, it's like, I'm thinking about the energies and the thing and that. And I'm like, I don't know. So Robin says, you really ought to ring that thing. And I'm like, okay,
right.
Here we go. So I hung that plate, and the video is on Instagram. It's actually pretty funny. And I started whacking that thing with a big mallet, and it rang a lot, like loud and long. Which, by the way, if it was a piece of cast iron, it wouldn't, because cast iron inherently damps. It has losses in it. But this was a piece of mild steel. So I don't know how many times we hit that thing to maximum volume, but it had to be 200. And my daughter came down to the shop, and I handed her the mallet, and she's smacking the thing, and we're having a great time. And the dogs across the street are howling. And it was like, it was. So then I went ahead and I did all the work on it, and I finished the grinding. Well, that sucker did not move. So did it work? That was not a scientific experiment. I didn't have a control, but right. I'm pretty happy. So it came off the grinder, and I put it on the surface plate, and I ran all over it with my tenths indicator, and I couldn't find anything. So did that grinder do its job? I think that grinder did its job.
I think so.
So that's the story. So I've been making PFG stones like a madman, and every time I learn something new about how to use them or how not to use them or process, I post it to pfg.gg, which is the product information page for PFG stones. I don't hold anything back. If I learn a way to take care of them or a way to use them, I get it out there as quickly as I can.
Definitely.
But yeah, and the trays that we ship them in, I consider that a trademark. It was the very, very, very first set I ever made is the same as the last set I shipped as far as the trade dress and the look and the feel, except they're better. They're better.
Right.
They really are better. I have a stupid grin on my face when I'm cleaning these things and I feel them, and it's like, it's good that it's still fun.
Oh yeah, yeah. So are you using a Prusa to print those, or?
Okay, so I have 2 3D printers, and I will use both of them. So you might get one on the Mark II, or you might get one off of the Lulzbot Taz 6. So my first printer was the Lulzbot Taz 6, which is a bigger machine. And I got to tell you a funny story. Eddie Reese, who is on Instagram as Spacely Guitars, who, by the way, is a craftsman. So look at the Spacely Guitars page. He does some great work, and he's building this gantry mill called the
Junkyard Datron.
Right? Junkyard Datron, right? Yeah. Or the Jankotron or something. Anyway, he's having a lot of fun, and he does wonderful work. He said to me, he also knows his 3D printing, and he said to me one day, you should go. So 0.4 inches is the nozzle. 0.4 inches. Listen to me. It's like a fire hose. 0.4 millimeters is what comes on the Prusa, and I think on the Taz it was 0.3 or it might have been 0.4 also. He says you should go to a fire hose. You should go to a 0.8. And I said, that's a brilliant idea. So the Lulzbot has been running a 0.8 millimeter schnozzle for forever now. So now I have the Lulzbot runs the 0.8 and the Prusa has the factory 0.4. And that's how I left them. So sometimes you'll get a tray from me. If you look on the edge, you'll see, oh, this was done on the 0.8. Oh, this was done on the 0.4. They both work great. And both of those printers have been awesome. The only one I had a problem with is on the Lulzbot, I wore out the bearings in Y, and I designed my own replacements. I posted it. It's actually on Thingiverse also. McMaster Carr Teflon bearings, McMaster Carr hardened. Are you listening, Lulzbot? Hardened rods, and then a 3D printed housing, which of my design. And one of the Y idler pulley holder cracked, pulled apart at the laminations. I reprinted it in PETG, and it's fine. So both of those machines have just been workhorses. They just keep going and going and going. Happier than I can be.
Awesome.
I won't lie though. I'm sort of kind of thinking about getting rid of the Lulzbot and getting 2 more Prusas, so I'd have 3. But honestly, I can't do my 8-inch trays at the moment on the Prusa. I might be able to, but I think it'll take a little bit of a redesign to just squeeze it on, whereas I can do a 8-inch tray on the Lulzbot.
Yeah, that makes sense.
And to put a ribbon on the 3D printing, PETG only, all the time, full stop.
Yeah, it's my favorite material as well. So before we jump into questions, the last question I had is kind of a chicken and the egg question. But what came first, your balancing ring or the PFG stones?
Definitely the PFG stones.
Okay.
PFG stones came first. And, well, there's a little hint there, right? I was grinding without balancing. And as part of my process improvement, one day I said, I think I need to balance these things. What do you think there, Murphy? So I start reading about balancing. And I go, and I wrote about, I think on the website, I have a little story there. And I do what everybody does these days. I go to YouTube and I start studying, how do you balance these things? So one of the first ones I find, and this is by no means a derogatory comment, I find Don Bailey of Suburban Tool teaching how to balance a wheel by taking a drill press and a carbide drill bit and drilling out blind holes on your wheel to remove material.
Right.
After I puked, I said, are you serious? So when you start, when you first learn how to grind, it's like you take out the raw wheel, you wring it carefully so that you make sure it's not cracked.
Right.
Safety first.
Mm-hmm.
You make sure it has the blotter papers, has to have the blotter papers on both sides so that it has a tiny bit of cushion between the adapter or the hub and the nut. Then you clamp it on there, and then you put it on your balancing stand and check, and you mark it, and then you start drilling holes in it. What are you guys, crazy? So it was like, now look, I know there are guys out there that have been grinding since before I was a pup, and I respect that. But to me, it didn't make any sense. So then I started to say, oh, I want to balance this thing. Surely there's a way to balance it. And the only thing I found was these Sopco makes a pair of rings. They're actually pretty clever. And you put them on the hub and you twist them, and you can move some mass offset. And I priced them out. They were really expensive. So I said, gee, there's got to be a better way. So again, you wake up on a Tuesday and you say, I got an idea. So I made the first balancing rings, and which are now the B200 balancing rings on my website. And those are still in use, by the way. Number 1, number 2, number 3, they're still downstairs on hubs in use. And they worked awesomely well. And if you're not familiar, it's a ring that has many threaded holes, and you move set screws around to move mass around.
Right. It's like a wheel weight for a car or motorcycle tire.
Exactly. And that's what I was thinking. So I experimented with screws, and I could put lead shot in there, or it should be brass, it should be steel, it can be plastic if I need a microgram, all these things. And then I went to, so I that was prototype number 1. And then prototype number 2, I go to put the ring on, it doesn't fit. I'm like, wait a minute, Sopco, your tolerances are, you make these things, people are making micron things with your product, and I can't. So then I realized, of course, you idiot, it's that diameter doesn't matter.
Right.
Why are they not going to control it to a micron? So then I thought about it, and I came up with the 3-contact mount, which is in the balancing ring. So if you look at the balancing ring, look at the pictures, you'll see there's a bump at, spaced 120 degrees apart. There's 2 bumps, and then there's the set screw. And what do you know? It's a 3-jaw chuck.
Right.
So now I have a little play in what that hub can be and still mount the balancing ring. Now you think that's pretty good, but wait, there's more. If you think about it, you're not distorting the tube. So let's say you could get the ring on now with just a hole, right? So it's 5 thousandths bigger than the boss. You slip the ring on it, you jam your set screw in. What are you doing? You're taking 2 fingers and you're squeezing the tube. So now you got this tube distortion, and I was able to detect it in the taper. So in the taper of the hub that mounts on the spindle, I was able to detect the pressure from that set screw. You had to give it a little gronk, but there it was. So the other thing that my mounting system does is it's a 3-point mount. It reduces the deformation of the tube, just like when we're using a lathe. If we want to really reduce deformation, you increase it maybe from a 3-jaw chuck to a 6-jaw chuck, or you go to a collet. Well, the collet answer would have been wonderful, but it's expensive.
Right.
And it turns out in practice that the design that I have shown in the present invention Can you tell I've written a few patents? It works great, and it reduces the deformation of the tube. It gives you 3 points of contact. It allows for variation in the hub. The only downside is you need the boss on the hub. So unfortunately, I had one customer who I really wanted to help, Pragmatic Lee in the Tin Barn, ordered up a ring, and he's like, "Oh, I got the wrong hub. My grinder uses a different hub." And I'm like, I was bummed. So he returned it. But it is designed for the Sopco 200.
Right.
So I started balancing my wheels, and then I didn't have a balancing stand. So of course, what do? You make one.
Yep.
So I made a balancing stand out of some 1, 2, 3 blocks on my surface plate. So my surface plate is I was able to level it. So I have leveling feet, and I leveled it, and I put these things. So my first balancing was done using a homemade arbor, using my balancing ring, and using a jury-rigged balancing stand. That, of course, led to building my own balancing stand, and that is pictured in various places on Instagram and on the website. And I keep promising to come out with it as a product, and I am happy to report it's coming out real soon because the design is done. The CAD is almost done. The raw materials are purchased. I have 20 sets sitting down in the shop. So yeah, really and truly, my balancing stand is coming. And I started balancing my wheels, and I started learning about balancing. So not only can I confirm that, drilling holes in your wheel is not necessary, folks. And I personally think it's a horrible idea, but that's just me. But it works. It works great. Now, the next step leads to a promise, which is as yet unfulfilled, which is I think I finally found a way to teach how to balance a wheel.
Oh, wow.
And that is not trivial. And I've seen all sorts of explanations of how to balance a wheel that is like crazy complicated. I think I finally came up with a way to do it and teach it that's simple, that uses the balancing ring, or it could use really any of the methods. And that will be coming soon in the form of a video. But my first priority is getting the balancing stand done so that when I teach everybody how to balance a wheel, they can buy the balancing stands. So that is a future product on the way, in the pipeline, for real.
Okay, awesome. Well, let's jump into questions. So you answered quite a bit of Fort Manufacturing's from Patreon already, how you got into designing antennas. He also asked, what's the strangest thing you've designed an antenna for? And then I think the other one that you haven't answered yet is, what are the tolerances on antenna parts?
Your question was, what are some of the weirdest antennas I've ever done? Oh my gosh. So I designed antennas for the Red Bull. Red Bull had these wingsuit races.
Mm-hmm.
They jump out of perfectly good airplanes and race around a course wearing these wingsuits. And without passing any judgment on the sanity of any of the participants, a buddy of mine who had brought me into a big company that I can't mention to design some stuff that I could talk about it. There's something public about it. We designed tracking units for special operations forces during selection process. They go out in the field and they do stuff. And they wanted to know where every soldier was, but also they wanted to know some of their biomechanical data.
Right. Telemetry.
Breathing rate, heart rate, temperature, that kind of stuff. So that company designed a box that was Kinetic, which was formerly Foster Miller. And so we did that successfully. And the reason I say I could talk about it is because it was actually on a National Geographic show. They showed that. And in that show, they showed that they're in the command tent, and this was sort of the maiden voyage for the system. So my buddy, who's the engineer on the project, is actually in the show, and they're all standing around late at night. It's like, dim lighting in a tent somewhere, and one of them is pointing to a screen and says, "Hey, look at this guy. His heart rate is like 40, and look at his breathing." That guy's asleep. So this was a guy who's supposed to be on patrol, right? And it's like, look at number 34 is sleeping. So, the drill sergeant, man, no, not drill sergeant, but it might have been drill sergeant. They up they go. They jump in the Jeep and they drive to the coordinates, right? Because they know where these guys are within a foot. And they go looking around. They don't see the guy. And they see a lump on the ground covered in leaves. And they go over it. Sure enough, the guy's under a pile of leaves sleeping. And the next thing you see is him being put on a truck and sent home.
Oh, so no.
Yeah. And by the way, all of that's public. Again, it's some National Geographic thing. See if you can find it. My antenna was in that guy's rucksack. Okay. So that was, antennas that are embedded in products is something I've done a lot of. So a company would be making, I'm holding up an iPhone, but I do not imply that my stuff is in the iPhone because it isn't. But they'd be making a product and say, hey, we need an antenna to fit in here, and they would call me up, and I've done many products like that. So that's an example of something that we did for a special application. There was actually 3 different antennas inside that black box on the Soldier that I designed.
Very cool.
And I don't remember. We bought an off-the-shelf antenna for the base station. So that was a weird one. So the same guys called me up one day and they said, "Hey, we're going to do this thing for these parachute jumpers, and we need to track them." And I said, "Do I have to jump out of a perfectly good airplane?" They said, "No." I said, "Let's go. I'm ready to." So we designed, again, a body-mounted tracking system and ground-based. So I designed both sides of that link also. So these guys would jump out of helicopters at, I forget how high, and they'd fly around a course, and then they'd land, and they wanted altitude and position in real time. And then they had my buddy designed a scoreboard so people can spectate, because it's hard to spectate these things. So they could spectate and see the scoreboard. And he used a gaming engine. And I'm going to leave his name out because he actually currently is working for another company, and I don't want to ruffle any feathers, but he knows who he is. So that stuff not only worked, it was spectacular how well it worked. So I couldn't have been happier. So then we get a weird call. My buddy calls me up and says, Red Bull was so impressed, they need some help on another project. Well, it turned out to be Felix Baumgartner.
I was wondering if you were part of that.
Yeah. Setting the free fall record. And basically, I'm going to say this very gently. They said, we've got 2 systems on him, and we need help. We need a 3rd system because they had a reliability issue. Mm-hmm. So I said, sure. So we could do that. So they sent me some pictures, and without divulging any details, I said, yes, you need some help. So we designed, we took our box that we used on the Soldiers and we modified it and made it fit on Felix in his belt pack. And so now there were 3 systems tracking him, and ours was one of them. Well, when he set the record for the highest, when he broke the first record, so, there was a 90,000-ish foot record that was set previously. When he broke that record, we were on him, and our data was what documented his breaking the record because the other systems failed. That was cool. So then came the big jump, right? Mm-hmm. And of course we're on pins and needles, and my phone rings, and it's my buddy who is on site. He's out in the desert, and he says, blah, 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 weather, blah, blah, blah. Well, remember, I'm also a pilot. So up come on my screen, I'm now pulling up FAA and other sources. Actually, it was the other sources that saved the day, National Weather Service aviation sources. And we were able to real time deliver back to him the weather data that they needed to make some decisions. It was crazy. But Felix jumped, broke the record, and our data was part of his record information. The interesting thing was that when he broke the sound barrier, we think there was a vibration or something that effectively pushed, those dome switches, those so-called dome switches that are underneath, there was a dome switch in our system, and we think it vibrated enough to activate that switch and stop taking data. So the data was received. Oh, there's one more story about that. The data was received, but they had to piece together the data from our system and the other systems that also had failures, but they ended up with a complete data record.
Wow.
And he broke the record. So when we first came into this project, the thing that triggered us being brought in because the other systems weren't reliable, and this is publicly documented now, it wasn't then, Felix was claustrophobic. So you're going to take a claustrophobic guy and let's put him in a spacesuit.
Yeah, and then inside a small capsule.
Inside a small capsule, right? At under a balloon at 128,000 feet. So Felix actually, and he documented this, he had issues, and he had to break through this barrier that he had of really super high anxiety putting on the suit. And the rest of the story, he did.
Right.
But here's what happened one day. One day he lands in the desert. They're doing a training jump, right? Full suit, but not super high altitude. He lands by parachute in the desert, and the helicopter doesn't know where he is. And they lost him. And for 40 minutes, and the rest of the story is he can't get out of the suit.
Oh my goodness.
So for 40 minutes in the desert, you got this guy who does not want to be in this suit. And when they found him, let's just say he was an unhappy camper. So that's when our phone rang. It's like, can you do something to help find him?
Wow.
And we're like, yes, we can. So we made a tracking system at 900 megahertz so that the helicopter, we put an off-the-shelf antenna on the helicopter, and then my stuff was on Felix, so that when he landed, they could find him, and that time was down to minutes. Like essentially, they were on top of him when he landed.
Right.
And that was really important. So okay, so there's a lot more to that story, but let's get on to other weird stuff. I've designed an antenna that's been thousands of feet below on a UAV that then would pop up and talk to an asset, as we say in the business. That's all I can say about that. Let's see. Oh, I designed an antenna that went on a horse's hoof.
Oh,
okay. Wow. You wanted weird?
Yeah.
I'm digging them out for you. So company came up with a way to measure the stresses in a horse's hoof as it trotted, ran, galloped. And I needed to design an antenna that went on a flexible circuit board that can be the telemetry antenna for that process. And I did. So my antennas have been on horses' hooves. I've been implanted. Let me clarify that. I designed antennas that went into devices that went in the human body and literally transmitted telemetry out of the human body.
Oh, cool.
So that all had to be modeled, and the constraints were crazy, and the clinical trials were in pigs, and they said, you want to come down and watch the clinical trial? And I said, no, thank you. But the antennas worked, and that was a good thing. Yeah, I've done a lot of weird stuff. So satellite communications antennas, we designed a system where the antenna per se was not my design, but the positioner and the packaging and all that kind of stuff and other parts of that were interesting. We took a 400-pound suite of equipment that the military was using for high bandwidth download in the field and turned it into a 40-pound rucksack portable receive suite of equipment. And that's presently a product being used in special operations. And one of the weirdest things is not an antenna. I teach a course for special operations on antennas and improvised antennas and how to use them, how to make them from junk, because we use the word crap, antennas from crap. And that's an ongoing concern. We've been doing that for years, and I've got students literally all over the world
That
using
is
that
certainly
knowledge.
weird and certainly cool. So
Didn't see
the
that.
other part of his question was, what are the tolerances usually involved in antennas?
So when you think about antennas, everything you think about has to be with respect to what the wavelength is of the radio signal you're dealing with. So, for example, a 300 megahertz radio signal that puts it higher than the FM broadcast band, but lower than Wi-Fi. Okay, a 300 megahertz radio signal has a wavelength of 1 meter. Okay, and then it's proportional. So a 3,000 megahertz or 3 gigahertz radio signal is going to have a 0.1 meter wavelength. So even a Wi-Fi antenna, which is 2.4 gigahertz, a wavelength is going to be 4.8 inches. So 1/1000th of that is 4.8 mils.
Right.
So it's not like wacko crazy in terms of the size of the antennas. Sometimes you end up with like printed circuit boards that have microstrip transmission lines. Those tolerances can be tighter for other reasons, but the antenna itself is not super crazy.
Okay. So how far out of shape can an antenna be before it starts dipping out of that wavelength?
In general, I'm going to give you the lawyer's answer. It depends, but I could say that a hundredth of a wavelength is a pretty good answer to that question.
Okay.
So if we have, a hundredth of a wavelength. So figure out your wavelength. If you kind of walk up to it and bend it by a hundredth of that, you're probably not going to have a big effect. So now, having said that, when you get to really high frequencies like 30, 40, 50, 60, 70, 80 gigahertz, which, point to like cell tower point to point is doing 5 gigahertz. There's 30 gigahertz point to point links, automotive anti-collision radar on go buy the cheapest car you want to buy. If it has, the anti-collision radar, that's 47 gigahertz.
Wow.
So yeah, it's starting to get into some crazy stuff that could start to demand some precision and repeatability. And it has to be within tolerance.
And then let's see, our other questions. Adam the Machinist had asked if you took any machine shop courses in college, which you answered you more or less didn't, but you had your introduction there.
First of all, let me say something about Adam the Machinist. I think he is a wonderful teacher and a magnificent tool maker and grinder hand. So he's one of the guys that if he speaks, I not only pay attention, I'm like the guys, following around the North Korean dictator with their little notebooks. I'm taking notes. So not one course. The only machining training I have ever received. Let me think this through. If is this truth? Am I about to speak the truth? Yeah, that welding course I took was the first formal education in any of our arts that I took, and the scraping course was the second. And I think I've never taken a course in machining.
Amazing.
It's been the school of hard knocks. It's been mentors. If you have an expert, listen to them, watch the hands. Always watch the hands. That's how I learned everything.
Awesome. And I completely agree about Adam. I'm pretty much, when we're done with this, going to go listen to the new Precision Microcast.
I can't wait.
And then IGS Dan had asked, do people improperly using your glorious PFG stones make you cringe? Do you have to bite your tongue?
Excellent. I will address both of those because full disclosure, I was supposed to have lunch with IGS Dan today, but we went long recording this and I've had to push that out. So I'm coming to have lunch with you, Dan. So the first question, does it make me cringe? Cringe is an understatement. I lose sleep over this. I've had to go into counseling because of this.
So when Ed was talking about deburring plates last week or 2 weeks ago with his stones?
Yeah, I took 3 different medications. Look, here's the thing. Who among us has not used a Craftsman cold chisel to open up a can of paint? Okay, I get it, but the beauty of the PFG stones is, and I demonstrate this in a video on my website. If you scratch it, right, you're removing material. And even if you raised a few boogers on either side of that scratch, when you go to the conditioning phase and you're rubbing one stone on the other, it cleans that off, and it's still completely useful. I mean, why else would you have stones? I mean, Starrett sells stones for cleaning gauge blocks, and those stones are serrated, right?
Right.
So, yeah, you could remove a little material and you're okay. The thing that is most problematic right now is loading up the stone, and in particular, using it on aluminum.
Mm-hmm.
It's sort of good news, bad news. The good news is it actually works on aluminum really well. The bad news is you can load up your stone, and that is not going away easily. So Adam suggested cleaning the stones with sodium hydroxide, which will dissolve away the aluminum. I believe this will work, and I have not tested it. So, stay tuned is the answer there. But yeah, it makes me a little crazy. But hey, if you wear out your stone, you might have to buy another set. So what the heck?
Right. Yeah. Well, I was actually really glad I listened to your live stream where Adam asked that question and you talked about it, because I was thinking like, oh, I might have to send these back to get them reground, and then turned out they were just loaded up, and I cleaned them pretty well. And
the sodium hydroxide idea came from Adam, and it's not new. People have been removing aluminum from their carbide cutting tools using sodium hydroxide. That works. So I just have to make a little time to take a stone, load it up with aluminum, and then go try it. And if somebody else wants to try it first, let me know, and we'll work together.
Awesome.
I enjoy it. Yeah.
Well, then, we kind of already went over shop news, new things. You've got a new machine incoming, hopefully ASAP, and you've got a new product coming out, which is fantastic. So that leaves us the last question I ask every guest, and that's, what have you been researching this week?
Oh, that's a really good question. What haven't I been researching this week? I've done some. There was some electronic things I was researching this week to do some repairs. That's kind of boring. What was I researching this week? I did not prepare this. I'm reaching over on my desk. So this is the Norton Sharpening Products and Dressing Sticks catalog, which is catalog 200, freshly downloaded off of the interwebs. I will point out it is also dated 2008, 2009. Clearly, this is an industry which is moving at light speed, but we may come out with some other stones. And I was researching that. One of the things I kind of want to make is a single grit stone. Don't get me wrong. I like the dual grit stones, and they have different purposes. It's not the grit, it's the space between the grits that's important once you're talking about a PFG stone.
Right.
But I was thinking about, it might be cool to make a single grit stone. So I was researching what's available out of the Norton catalog. I don't buy random imported junk just because it's cheaper. I just go to Norton.
Right. Well, and your minis are single grit, aren't they?
My minis are single grit. So I sell them as one of each grit. And I suppose if somebody, asked for it, I just thought of that. You just made me think of something. I could make it an option to get two of the same grit if somebody wanted that. That's no skin off my teeth. So I was researching stones. Crazy for a guy that sells PFG stones, right?
Yeah, I never would have guessed it.
Yeah, I know. But that's what I was researching this week.
Well, awesome. Well, thank you so much for taking all the time. I'm sorry you missed your lunch. I really appreciate you coming on the show, though. I learned a ton about things that I did not think I would learn on this show. So I think I
warned you. I think I warned you that it was going to be a surprise.
Yeah, you were 100% right. And I really appreciate you coming on. Real quick, before we wrap up, I've got a couple Patreon thank yous of new patrons, Moritz and Patty Mullen. Thank you guys for joining the Patreon. Help support the podcast, helps keep it going, and make it a little easier on me while I'm trying to do a million things. So thank you again, Spencer. It was fantastic to get to talk to you. And thanks everyone for listening. We'll be back next week.
Thank you, Dylan.